say anything incriminating.
What's that?
Don't say anything incriminating.
Oh. The tape is on and rolling. Way off. Yes. Okay. Say hi to the camera.
Battery's gonna run dead.
Can you plug it into power and run it?
Yeah, I think.
Because we've got the electric outlet right here if you got a cord. I've got some extensions for it quickly. But it's good for everybody because then the sun, the shadow is way up here and people can't walk in front of it with their cowboy hats on and say, oh, where'd the shadow go? We see that on our sites where people run with their, walk by the site, look at things, and then all of a sudden you see this divot in the data. So they put their head over the top of it looking at it.
Can you adjust that thing when you want?
Let's see. Yeah, go ahead and put it. Yeah, we did. Alright, well I guess we're... Yeah, go ahead and use what you need. I'm going to go grab one of our bottles. This bracket typically put up here. Do you have a preference on, from your experience with these Vizsla probes, is east side better or west side better from the standpoint of your...
No, shouldn't be shaded. If you put it here, then when it's west, sun's there, then
Yeah, there's,
Usually I put it south.
yeah, we don't have that option. I have east or west.
You can put it half of it at least, like that.
No. Well, I can go part way, but
Because anyway, it's long, it's up to here.
yeah,
It would
I
be
just
good to
need-
be farther to here.
yeah. Get there here, probably this way.
All mine are in
South or southeast?
southwest.
Southwest?
Southwest.
What's that? Let's take them out of here. Can you get the others out?
I have a hacksaw. Slide this on the side.
No, it just locks right there. That's probably set up for a different mounting arrangement. So they have multiple locks. If you mounted this directly on this plate, that's why you have the bigger holes. That's right, these are metric. No, leave it on. I just want to see if I've got room here to clear it. And so, plenty of room.
That's what.
Hey, the sun's out. Shadows. Look at that. Well, it's not 7/16. Not 3/8. In between the two of them. That's why I was using a quarter. It's a metric. It's probably 10 or 11. And I didn't bring any metric stuff with me. This would be wrench. Yeah, I got it. It's definitely tight enough. It's deforming the
Deforming?
deforming the nickel. Yeah, you can see the bow now. That's fine. Let's see, how close are we to solar now? About 3 hours. What's that? Oh yeah, the stand always does. In the wind it will rock. They all do. Okay, so now, since we don't need to move this down, it's in the wind.
I'll show you in a couple of pictures. And I had to run up to the lab and borrow somebody's digital camera because I got such good scum. So I needed to get good pictures of my great scum. So glomalin is a biomolecule produced by a class of fungi that actually forms what we call scum. And I'll show you some pictures of scum and give you an idea of what that looks like and how that may contribute to soil structure. And am I going to move on? Nope. Somehow that went away. Okay. Can I back up? All right. And I'm going to start off with, I was here over the summer, and some of you have seen this already, but just kind of a brief demonstration on, these are from soils out at the Mandan Station, so they're North Dakota soils, and let's see if I can get that in a little bit better focus. Yeah. I have 3 different types of soils. They're a no-till, a conventional till, and a pasture system. And these are 1 to 2 millimeter aggregates that were dry sieved out of these soils. And some of the things that I'm going to be talking about in reference to soil structure is looking at soil aggregates and the importance of not just the amount of aggregates that you have in there, but water stability of those aggregates and how that contributes to soil structure, and the role of aggregation in a number of issues such as erosion prevention and nutrient availability. And so I've got my dry sieved aggregates. They all look about the same as they're dry sieved. They're all to the same size. And now I've got my simulated rainfall that's going to come along here. And as I said, there's a difference when you're looking at aggregate formation and aggregate stability is one of the bigger topics, and it's because you may have aggregates that are formed, but if they're not water stable, they're not going to be around for a long period of time, and if you get a rainfall event, such as my simulated little rainfall here, you're going to start to lose these aggregates. As you can see, I'm not spraying directly on, so this would be kind of the effect of if water was sort of percolating into the soil as opposed to some surface disruption. And it's a little bit hard to see. In fact, you might not be able to see it very well. The soil from these pastures, the aggregates from the pastures, actually don't wet up as easily. You can kind of see that there's sort of a wetting front. They float on the surface as opposed to getting wet very quickly. And that is related to my topic as far as scum is concerned. So I'm going to shake these up a little bit. We've got a little bit of disturbance going on here. And then I've got my floating pasture aggregates. And what you can see here is that in a conventional till system, most of the aggregates are broken up. So if you had water that was going to come into there, your aggregates are going to burst and you're going to lose whatever nutrients and topsoil that you would have within those aggregates to erosion, either the water erosion or subsequent wind erosion after you've broken up the aggregates. In the no-till system, I've got a little bit better aggregation, and in the pasture system where I've not had any tillage, I have really great aggregation. In fact, measurements on this is 93% stable, 58, and 23. And that's also correlating well. The bottom number there is TP, and that's total protein, and that relates to, it's a measurement of glomalin that's in our soil. And the higher concentration, when I've got about 8 milligrams of protein per gram of soil, I have much higher aggregation in that soil. So there's sort of a correspondence that you can kind of see here with glomalin relating to that factor that's going to keep your aggregates water stable. And what I'm going to attempt to do, sort of, is to explain a little bit of how that works, why that works the way that it does. And to start off, just give you an idea of soil structure and some important components of soil structure that I'm going to talk about. Organic matter. When you're looking at organic matter, what I've started to look at is to separate organic matter out a little bit differently and have 3 different components of organic matter. You have your biologically active or your light fraction that is organic matter, plant debris that's going to be turned over very quickly. And then you have organic matter that's physically protected, and that's going to be within your various aggregates. And that can be some of your your particulate organic matter, some of your plant debris that actually when it's within an aggregate will have a longer turnover time. So you can keep some of that organic matter in the soil much longer, and it's not going to be as susceptible to microbial degradation because it's physically protected within those aggregates. And when you have those really highly stable aggregates, that organic matter is going to be protected in there for a much longer period of time than when you have something that's disrupted. In the conventional till system, when those aggregates are disrupted, the organic matter that may be within those aggregates is now exposed to microbial populations in there and is going to get degraded, and you're going to have that turned over very quickly into the system. And then you have fractions of organic matter that have always been called your humus or your humic acid, and it's a chemically inert fraction of organic matter. Your plant debris in the soil will go through several stages of degradation, and kind of sort of the end stage is when it becomes more humified matter. And that can have residence time to up to several thousands of years within the soil. But it's a very small fraction of the original plant material that you had, because most of it's gone through microbial processing before it becomes chemically inert. The other issue that I'm going to kind of be touching on a lot in soil structure is the concept of aggregation. And aggregation is very important within your soil. Some of a good soil quality indicator is soil aggregate stability. So when you measure with the 93% pasture soil that's 93% stable, it has good quality soil. And aggregate stability is important in porosity and aeration, which can be important in water and aerobic relationships in your surface soils. And that's related to plant and microbial growth. So you have different fractions of nutrients that can be turned over within aggregates that are going to give nutrients to the plants. It also helps to keep those nutrients near plant roots as opposed to them getting lost from the soil. And it's very important, that whole concept is very important in the idea of erosion. And in this area of the country, you've got, this isn't as much, I'm over at Mandan, which is more of a semi-arid climate than here in Fargo, but you still have rainfall events that are going to be falling on dry soil. And when you have that happening, it's like the same simulated rainfall that I did there, is you're not going to have moisture humidified soil, you're going to have very dry soil that can be disrupted very quickly by rainfall events. And you have wind in North Dakota, just a little bit. And when you have that wind, the aggregates, the material that's disrupted in there is going to get lost very, very quickly to wind erosion. Worldwide, about a third of the arable land has been lost to erosion. Current loss rate is about 10 million hectares per year. And within the United States, that's 6.5 tons per hectare per year. So topsoil, where we can grow plants, the part of soil in which you can grow plants, is a precious resource that can be easily lost to erosion when improper management is applied to those soils, and you're not going to have the stability or the structure to your soils. And what I'm going to focus in on in relation to glomalin is issues such as aggregate formation, the amount of aggregates, and as you saw in the Petri plates, the amount of aggregates I had was about the same. They were all about the same amount of dry sieved aggregates. And what contributes to aggregate formation and contributes to aggregate stability is going to be your really important factors. A lot of people go out and measure the amount of aggregates that they get out of a soil, but if those aggregates are not water stable, they're not going to be there for a longer period of time. So you want to look at some other issues when you look at just aggregates. There are a number of processes that contribute to aggregate formation, a number of physical and chemical properties, and properties that, along with that, involve a number of inorganic and organic compounds. So it's a very dynamic sort of formation process, a very dynamic sort of stabilization process. And it's a little bit hard sometimes to get a handle on what may be the primary things that are helping aggregates to form and keeping aggregates water stable. What I look at mostly is this biomolecule that seems to have a strong contribution to aggregate stability. There's also a lot of evidence out there that within aggregate formation, in order to form aggregates, if you have a component of plant roots, fine roots, and fungal hyphae. And fungal hyphae can actually act like a net. That if you had a net that went through soil, that's like having a network of fungal hyphae, and you have this net that goes through the soil, and it picks up all of the plant debris and other types of organic matter and your clay particles and silt particles and sand particles, and puts them all together and keeps them kind of captured within this net. And within that net, then, if you have different biomolecules that help to glue them together, bacteria produce polysaccharides. It's like glue or chewing gum is kind of one of the things that I talk about. If you ever see chewing gum that's on the ground and it's got all of the stuff that's stuck to it, that's the polysaccharides that the microbes are going to be forming are going to be this chewing gum within your net. So you now have this net that has all these particles around there. You have this chewing gum that helps keep them stuck within that net. And now what you need to do is have something that's going to coat that outside of that net to sort of keep it water stable so that the chewing gum doesn't break down when water comes along and you don't start losing all of those things out of the net. And that's where things like aliphatic compounds come along. And glomalin has some aliphatic or hydrophobic characteristics to it that are going to help to provide that coating. This is a picture to give you an idea, not just from looking at what I had in the overhead, but what aggregates actually look like. This is a microscopic picture of an aggregate, and then the electron microscopic pictures of the different components that are within an aggregate. And you have, this is a macro aggregate, so it's greater than 250 microns. Microaggregates are smaller than that. The idea is that you have microaggregates that actually are meshed together by that net, by the fungal hyphae and plant roots to help form a macroaggregate. So within a microaggregate, you can find, or within a macroaggregate, you can find microaggregates. You'll have that fungal hyphae, the hyphal network that sits there. And if you kind of look pretty closely at the fungal hyphae there, you can get an idea that it has, the hyphae kind of has a little bit of an amorphous coating on it. It sort of has an uneven texture to the surface of the hyphae. And that's where it's sort of kind of some physical evidence of what we can see that may be glomalin that's on the surface of this hyphae. Along with that, you have plant roots that can help with kind of this net. And then, as I said, you have bacteria that form some of these polysaccharides. And if you look scale-wise, again, bacteria are very, very tiny. Within a gram of soil, you can have millions to billions of different bacterial cells. And within that same gram of soil, you can also have hundreds of meters of hyphae. In some native soils, you can have up to about 500 meters of hyphae within that gram of soil. But scale-wise, if bacteria were the major contributors to keeping this macroaggregate stable, you'd have to have a lot of bacteria, or they'd have to be producing a lot of microbial byproducts in order to keep that whole big thing stable. But if you have the hyphae on scale is much larger than that. And when you have this coating that's on the hyphae, it has more contact with a much greater amount of the surface area of that macroaggregate. What I'm primarily working with is a byproduct that's produced by a class of fungi called endomycorrhizal fungi. These are, or VA, or vesicular vesicular mycorrhizal fungi. These are fungi that are associated with greater than 80% of the vascular plants. They co-evolved with plants when plants first came onto land. So they've been in a relationship, in a symbiotic relationship with plants for greater than 450 million years. So this is a very ancient relationship, and it can have a lot of different impacts on the plant host as well as the surrounding soil. And this just gives you an idea of a little bit of how they work. These fungi themselves are obligate biotrophs, so you need to have a plant in the environment in order for them to grow. The plants, not all plants need to have these fungi, but the fungi need to have the plants. And this picture and the one up above there will give you an idea of the advantage of these fungi is that they can access a much greater area of the soil than a plant root. And from that picture, you can get a very good idea of the size, the scale size. So the surface area of fungal hyphae can contact more soil that may be around in the rhizosphere of the plant than the plant root can. And that's very important when you're trying to pick up immobile nutrients such as phosphorus, because that you get phosphorus depletion zones that can happen very rapidly around the root zone. And if you can't go out and get the phosphorus doesn't come to you. So you need to have access to a much greater quantity of soil. And you don't have to grow very far away from the plant roots. It's, it kind of is a little bit analogous to like with a tree, and that the root is the trunk of the tree and the hyphae are the branches. And if all the leaves formed just on the trunk of the tree, you wouldn't get very good photosynthesis and you wouldn't get a very good, healthy tree, because it can't get enough sunlight just by having all the leaves on the surface of its trunk. That's why trees form branches, and they form finer and finer branches in order to have more leaves out there to access more sunlight. And the same thing happens below ground. Sunlight is the nutrient limitation source for is one of the limitation sources for the plants. For them to grow, they need to undergo photosynthesis. They need to fix that carbon. And below ground, you have other nutrients that are limiting, and you need to have the fine branches, you need to have the hyphae that's going to grow out there in order to access that. And the below ground, the picture below is just, it's an arbuscule that's formed within a plant root cell, and that's where the exchange occurs. These fungi are obligate biotropes. They need to have carbon from the plant. They can't make their own carbon. So all the carbon that they get is photosynthetic sugars that are produced by the plant. And I put that picture in for two reasons. One, this is how we know that these fungi have been around for 450 million years, is you can find that same structure in fossilized plant material from the earliest land plants. So this is a relationship that has been in existence for 450 million years and hasn't really changed in that period of time. And when you have something that's not going to change, it's very effective. This is one of the most cost-efficient mechanisms out there. So it is a very important mechanism, and it kind of shows you that the hyphae can be very finely branched, and you can have, there's probably literally close to 100 meters of hyphae within that root cell in and of itself, because it's so finely branched in there, and if you measured it out, it would be very long in length. Glomalin is something that has been identified on coating the surface of these hyphae. It was identified in the early 1990s. So there are things we know about it, and there's a lot of things we don't. It's a very wide open field of exploration in science. There's a lot of questions out there as to why it exists and some of the mechanisms, and I'm going to kind of give you an idea of some of the things that we found and why we think that this happens. The pictures that I've got in here that show glomalin is the bright green material on there. Glomalin natively is not bright green. We use a laboratory procedure with an antibody in order to make it immunofluorescent so that we can see it. And you'll find when it's on fungal hyphae that it sort of is kind of amorphous, and it has a little bit of differential deposition. And you can see that a little bit on the top one, but you can definitely see it on the bottom one. And this is from a pot culture system, and again, there's probably at least 100 meters or so of hyphae right in that, and it formed this rope to connect between, we had a nylon mesh that was in our pots, and those were what the little holes are, and this rope actually connects two holes to each other, so that it formed this net that was it's kind of like a spider's web going from one end, connecting one thing over here to one thing over there. So you had this rope that was connecting there so it could collect all of the debris, and in this case, they were in a sand pot culture system, so it was collecting the nutrients that were in our nutrient solution. But you'll get formations like that in the soil, and within that network, you can easily see that you've got enough there to sort of enmesh a lot of different particles. We think that one of the primary roles that it has is that it coats and protects the hyphae, And this coating that it puts on the hyphae, this molecule has some hydrophobic character to it, which helps it with the aggregation. In the fact, if you have something that's hydrophobic, it's a little bit like as if you have oil and water. And oil has hydrophobicity to it, and it sort of forms these they're like micelles in water. It doesn't mix. And if you have hyphae if you dipped your thread in oil and it got all of this oil that coated your hyphae or your thread, and now you can put it into an aqueous environment, and you're not going to have loss of you're not going to have the loss of the water and nutrients that are within the hyphae, because now the outside is protected. So you won't get loss of these nutrients across the hyphal wall that you would if you didn't have this coating on there. And it's a little bit like as if you had a pipeline. The hyphae act like a pipeline in the soil, delivering nutrients from one location to another location. And if you had pipe made out of cardboard, it's not going to work, because you're going to lose the water in your pipeline across that cardboard. But you now have it made out of, you have PVC pipe that's coated with a polymer on the surface in order for you not to lose the water that's within your pipeline. And this also helps the fungi it can act like a carbon sink. In microbial communities below ground, a lot of them are driven by photosynthetic carbon. So carbon is your currency. The plant is your bank, and it has all of your carbon currency. And you want to if you want to be an effective microbe, you want to get as much of that money out of the bank as possible. So you need to maintain within yourself as an organism, you need to maintain a constant withdrawal system. You need to have money being withdrawn, carbon being withdrawn from that bank all of the time. And so they will form these type of biomolecules that in order to have some of the carbon go to that, so that it always needs more carbon from the plant. It's always knocking on the door asking for a loan from the bank, because it has to go and spend its money, its carbon elsewhere. Along with that, when the hyphae degrade, or when they're not functioning anymore, the glomalin that's on the surface of this hyphae, because of the nature of this molecule, because it has certain hydrophobic characteristics to it, it's very resistant to degradation. So the hyphae will degrade, but the molecule stays around. And what happens is that this becomes deposited on organic matter and soil particles. And from here, this is just a plastic mesh that we put in our pot cultures. We can put pretty much anything in our pot cultures. It sticks to sand, it sticks to glass, it sticks to plastic, it sticks to roots. This stuff will stick to this material, and this is a procedure. When we do the immunofluorescence procedure, we actually incubate it for several hours in different aqueous solutions. So it's something that actually really does adhere to these surfaces. It's not something that can be easily wiped off. And that's advantageous when it's sitting around in the soil, and when it's going to be coating these soil aggregates, because it's something that's going to get on the aggregates and not going to come off very easily. And this is sort of the stuff that I did recently to give you an idea of what I mean by glomalin being scum of the earth. And if you've ever noticed, if you go out and sample some soil, and this was soil that I sampled at the Mandan station, and all I really wanted to do was I wanted to clean up the roots that were in there, because I wanted to use the roots in a pot culture experiment to try and generate more fungi. And this is where I got all excited and had to run up to the lab, because I got really good scum. What ends up happening, if you ever notice, you put it in water, if you ever put a soil core or a plug of soil into water, and you'll get this debris, but there's also a little bit of, it's kind of like a film or scum, like soap scum, that sits on the surface of your water. And if you break up the plug a little bit more and agitate it a little bit more, you can get a lot more of the scum that's going to come out. And this is literally probably a lot of glomalin that's sitting there. I mean, I can't say for sure that 100% of this, but it's a good way for you to be able to see. I mean, this is a molecule that you can actually physically see with the naked eye when it's floating on the surface like this. So there's a lot of this that is within the soil. And this is I took a number of different plants, and what's interesting is that these were all plants that were separated by maybe about 30 feet. So this scum is not something that's generated just naturally with whatever is going on with the soil that's there. But there are differences in the amount of scum and the type of scum that you find based on the plant, and potentially then based on the fungus that's associated with them. So I had switchgrass. There's very little scum in the big blue stem, and then alfalfa that had a lot of, I mean, right away the alfalfa had this white foamy scum, and I collected it in a beaker, and I still have this layer of scum that I've got there. What's interesting about the big blue stem, and I was pretty alarmed because big blue stem is a very good mycorrhizal host. And I was a little bit worried because I wasn't getting a whole lot of scum and what was going on here. Well, when I started to feel around in this bucket, this big blue stem had really good aggregation in the soil. Really good. I mean, I had disrupted and broken this all up, and it's like that pasture soil where I could feel all these little pellets that's in that soil. And what happened was, as I started to manually break those up, I generated scum. So as I'm breaking those up, I'm releasing glomalin into that aqueous solution into the water, and it's now floating again as scum. So you have scum in the alfalfa. There wasn't a whole lot of roots. That whole system may not have been as developed as it was with the big blue stem and the switchgrass, so that a lot of that scum was being generated, but it was floating more on the surface of soil. And that can be important to glomalin deposition. You could get it to deposit into greater depths with soil solution. You can also get a lot of this lost to water erosion. If you don't get it collected on aggregates, you're starting to lose some of your glomalin that way. And my former advisor out in Maryland is doing some work down in Florida on mangroves, and what they found is they found scum in the water, and when she was doing measurements on glomalin, she started to lose glomalin as she went to a different location. And what they did was then when they went back and sampled the water, they were getting glomalin that was in the water. So it was still there, it was in that environment, but now it's in a different location because of the water at that particular site. So now we've got scum. We see scum, it's floating on the surface of the soil. How does that work? How does it get from the hyphae to water solution to helping you have stable aggregates? Well, there's a little bit of a mixture of cartoon and pictures here to get you to understand what may be happening. When you have aggregate formation, as I said, you're going to have hyphae that are going to help to entangle this. This hyphae is primarily a mycorrhizal hyphae, because that's one of the dominant fungi that are going to be there, and that hyphae is going to have glomalin on it. And it's also, glomalin is a glycoproteinaceous compound, which means that it has sugar groups, which allows it to act like chewing gum, as well as having amino acids, and a number of amino acids that are hydrophobic, which helps to give it that water stable character. So you've got this compound now that can help to glue together the debris that's around the fungal hyphae. And I wish I had some better pictures of this, and eventually I will get some taken, but that shows you can actually, if you try and clean up hyphae from the soil, it's like trying to clean up roots. You can't get all of the debris off of roots. It's impossible to do that, and it's because they have these polysaccharide molecules around them that help them to keep that debris and the microbes associated with it near the plant roots and near the fungal hyphae. So this stuff is in the environment, and it's in the mycorrhizosphere, or the rhizosphere for the plant. And you're going to have the glomalin is going to, that's the green stuff that I've got on my hypha, so it follows with the whole green immunofluorescence thing. The green stuff is glomalin, and this is a hypha that's starting to degrade, so some of the glomalin is sloughing off. And we actually can see this happening, as you'll get glomalin in some of our immunofluorescent pictures on hyphae that it'll be dripping off. So this is something that you can actually see it while it's happening. And then you get the scum. You get it comes off and it comes off and it's in this sort of scummy type of form. And these are, we call them scum bubbles, of course, because they're bubbles and they're scummy. And we can do immunofluorescence on that as well. And it's hard to see, get a good picture of it because it's a very faint immunofluorescence that's on the surface of those bubbles. But you can show that glomalin is actually there. Then the scum, somewhat with drying and possibly some with contact. We're not really sure of all the mechanisms that happen, but the scum will come in contact with the aggregate. And typically it will come in contact with the aggregate because the hyphae is help to form this initial kind of pre-aggregate. It's the pre-coated aggregate that'll be there with that hyphal network. And so the glomalin scum doesn't have far to travel. And it will come and it will coat the surface of this aggregate. The black lines on there are hyphae that's sort of growing throughout your aggregate. And then you've got some clay particles and organic matter and silt and all that stuff. And just so you know, this is kind of real. This is a 1 to 2 millimeter aggregate. And we've stained it done the immunofluorescence for glomalin. You can see in there the tracks of hyphae that you've got. This network here and here really well, that you've got the network that's much more immunofluorescent. Sometimes there's not hyphae there anymore, but we can actually see the track that the hyphae went through based on the amount of glomalin that's around there. But the whole aggregate has a certain amount of glomalin coating its surface. And this is stuff, again, that, like with here, was something that we put into an aqueous solution. In order to get the staining done, we put it in an aqueous solution and let it shake in different solutions for about 3 hours. So that is a very stable aggregate that's been shook up in water for a long period of time. The advantage of having this is that this molecule can do some pretty good things within the soil, not just with helping to form aggregates, but it can also help with things like storing carbon and nitrogen and organic matter within your soil. So organic matter can act as sort of a long-term fertilizer for plants that are in your soil. You want to have a lot of organic matter in your soil in order to have good soil quality, nutrient-rich soils. This compound is highly stable. It can have a minimum of a decadal turnover time that's been published and measured. There are some evidence out there looking at aggregates that it can have at least a century turnover time. So this is something that the molecule in and of itself can last for a long period of time. On top of that, the plant debris, the particular organic matter that you have within these aggregates, if you have very stable aggregates, will be stable, that carbon will be able to be stored for a much longer period of time than it would if it's free-floating carbon. When you look at organic matter, I'm going to sort of switch a little bit and talking a little bit more about organic matter. And when you look at organic matter, it used to be that the major 4 things that were constituted organic matter in the soil. Well, actually, there was kind of 3 major ones, and some of them were. It sort of oscillates between humic acid and fulvic acid as to what's. But you have your human or your humus, and when you look at soil, really good soil is kind of dark, rich. It's almost even a reddish brown color. It's not black so much as it's got a little tint of red in it. And that, whenever you look at that, people always say that that's got a lot of humus in it. It's a very humic-rich soil. So the majority of your organic matter is in that human or humic form, humus form. Then you have humic acid, which is HA, and fulvic acid, which are other types of humic substances that are more soluble and a little bit easier to measure than, or to analyze at least, than the humus form. And your particulate organic matter, which is your plant debris. And again, this is kind of an example. This pie chart was generated from data that was in a number of different papers in the literature. So the distribution can change a little bit, but that's pretty much the way that it goes. The majority of it's in human, and you've got about a quarter of it that's in particulate organic matter. When I started looking at glomalin as a component of this, it became very apparent very quickly that glomalin was actually a pretty major component of this organic matter distribution, and that some of this human fraction that people have had difficulty putting into solution, they consider it mostly insoluble organic matter, does contain some glomalin, and we use a unique extraction procedure to pull glomalin from the remove glomalin from the soil. We actually heat it up at 121 degrees Celsius for an hour in a alkaline citrate buffer. So it's something that is a little bit different than other people have ever tried to look at when you're trying to measure organic matter in the soil and solubilize those different fractions. In addition, because it's associated with plant roots and the fungal hyphae is associated with plant roots, there's a fraction of it that can be found in the plant debris fraction, in the particular organic matter fraction, contains some glomalin carbon, as well as the humic acid fraction. So there is the ability to co-extract. People who have looked at humic acid for centuries, about 100 years or so, people have been looking at humic acid, and they have co-extracted this glomalin and other microbial biomolecules along with humic acid. So when they're measuring humic acid, it's just this heterogeneous extractable material. They do an alkaline extraction from the soil, and it's operationally defined as humic acid because it's alkaline extractable material. When you start looking at the different fractions in there, you start to see that glomalin is actually an element of that. These are just some properties of glomalin, and I wanted to put this in because I found the pictures in here because it's really interesting to see when you start talking about as I said, the dark black richness of soil, and I said, sometimes it's kind of a reddish brown. This is from a Colorado soil. A undisturbed Colorado soil. The one picture, of course, is unextracted soil. So before I do the glomalin extraction, that's what the soil looks like. After I extract it, it's kind of like ash. A lot of that organic matter has been removed from that soil, and a major fraction of that organic matter that was removed from the soil, again, is this glomalin component. And you can see that in the bottom picture, that's actually a picture of extracted freeze-dried glomalin from 50 grams of that soil. So you can get a fairly measurable quantity of glomalin from those soils. Some of the properties of glomalin that make it very unique is that it does not dissolve very easily in water, which is contrary to a lot of glycoproteins. They're usually very water soluble. Because it has some of that hydrophobic character to it, it resists decomposition. It's harder for microbes to basically chew it up and eat it. It's very heat stable, which helps it to be very resistant, and that we can see by the fact that we extract it at 121 degrees, and we have one soil. We'll repeat the extraction until the solution is almost clear, and we have one soil from Hawaii that actually my former advisor finally made me quit because she said, we can't just do this forever. We extracted it 25 times in the soil, and we still got material that you can measure. So it's being exposed to heat repeatedly for 25 hours in 1 hour increments. So it's a very resistant molecule. And the reason that it can be so resistant is that it has a very complex structure. As I said, it's a glycoproteinaceous molecule, so it has protein and carbohydrates. Again, some of the amino acids are more hydrophobic, so that gives it more of an aliphatic or hydrophobic character. It may also, in its structure or within the soil, it may have a lipid component to it or an aliphatic component to it, and this would allow it to be anchored on the hyphae. So that's some of the complexity. It also, within the soil, can hyperaccumulate other atoms. Primarily iron is one of the ones we look at, as well as aluminum. So it can hyperaccumulate various cations, and that's what gives it some of that reddish-brown color. And glomalin, if you're comparing glomalin to humic acid is usually more of a black, like a charcoal color. Whereas glomalin has more of this reddish-brown character to it, and a lot of that redness comes from the iron that is on this molecule. So that's kind of a summary of what we sort of know about glomalin. Some of the objectives of what we want to do is find out how can we get more glomalin. There's a lot of it out there. It's been around for so long. It has some roles that we apply to it that we don't know for sure exactly how it does this functionally, but it has various roles that we've applied to it as far as some of the characteristics that it has. So we know that it's very important in the soil. And one of the primary things in knowing that it's important, it's ridiculous to say this, but because it's there and because it's always been there. We may not understand it as human beings as to what it's supposed to be doing, but it's there and it's always been there. So how do we get more of it? And some of the things that you can do to increase the concentrations of glomalin in the soil are various sustainable agricultural practices, no-till or minimum till. And that's very important because when you have tillage, it disrupts that hyphal network. And that has a couple of consequences. One, it can decrease your aggregate stability because you've now disrupted that net. You basically went through with an implement and tore up that net. And for glomalin, from a glomalin standpoint, everything, like I said, is on a carbon basis. The plant is your carbon bank, and you put your carbon as if you're a mycorrhizal fungus, you put your carbon into forming hyphae, forming glomalin, and forming spores. So this is all that you do with the sugar. This is your body. This is how you live. It's like as if salamander, you cut off the tail and it regrows another one. Well, the carbon that could have gone to, the energy that could have gone to something else now has to go to reforming that hyphal network. So every time you till, rather than putting carbon into glomalin, you have to put it into reforming the hyphal network. And that's where, the no-till, minimum till comes in. These fungi are natural, they're not natural fertilizer, but they're natural nutrient accumulators. So they will go out and get the nutrients that the plant needs to grow. One of the primary things, like I said, is phosphorus. And if you use phosphorus fertilizer, the plant, if you apply a lot of inputs, high phosphorus fertilizer, the plant doesn't need to have the fungus to go out and get its fertilizer, because all the fertilizer, all the phosphorus is around the plant roots. So it won't allocate carbon to this relationship. It will store all of that excess carbon in its own roots. It doesn't have to have microbial populations. Plants have naturally evolved with microbes because nobody was fertilizing them. And when you start fertilizing them, they don't have to have the microbes around them anymore, not just mycorrhizal fungi, but any type of microbes. Microbial population declines very rapidly in high input systems, and it's because all of the needs are satisfied by what man has fed them. But if you don't feed them anymore, they will form these relationships in order to try and satisfy their needs elsewhere. And it's not that this is actually energetically a much more efficient system. One of the reasons that people are looking at sustainable agriculture and reduced input systems is because inputs have become so expensive in the last several years, and that's going to continue to increase. It's a very high energy cost to make fertilizers that we apply to our agricultural systems. Crop rotations are very important, and within that crop rotations, that brings me down kind of to the second point of looking at mycorrhizal host plants as opposed to non-mycorrhizal host plants. As I said, about 80% of vascular plants are mycorrhizal. There are a few exceptions to that rule. Unfortunately, in this area, canola is the biggest exception to that rule. It's a non-mycorrhizal plant. Other plants in the brassica family are also non-mycorrhizal. primarily the non-mycorrhizal plants, other than these crop plants, are weedy species, and that's a carbon thing, because for weedy species they put all of their carbon into making seeds so that they can continue to grow and be weeds come around next year. But for perennial plant species, they will put some of their carbon into their roots so that they have that storage system to regrow the next year. That carbon that goes into the roots goes into the rhizosphere and the microbial populations that are surrounding those roots. So a crop rotation is good. I always say above ground diversity means below ground diversity means you can survive adverse conditions. And that's the important key here, is that you don't always have the perfect year. In fact, in my lifetime, I don't think I've ever seen my dad's in farming, and I don't think he's ever had a perfect year in my lifetime. You have drought conditions, you have early frost, you have late frost, you have rain too early in the season, there's always some adversity that you're up against. And it's like fertilizer. If you feed the plants enough that they can overcome any adversity that comes at them, they will not keep this relationship around, and they will not be able to, if you start taking that away, they will not be able to survive under various adverse conditions. You want to have this good diversity that's there, and you want to have it be associated with more than just one crop plant, so that when you plant, these are non-host specific fungi, but they have trends that they're going to get associated with. So when you plant, if you plant continuous wheat, and then all of a sudden you decide, oh, you know what, I'm going to put, I don't know, soybeans in this field. The microbial population has become acclimated to having wheat there, and you're going to start seeing some declines in yield and other issues like that if you don't have that above ground diversity. If you go and look at native prairie sites, they are plant diverse sites. They have legumes, they have forbs, they have grasses. You need to have that diversity. And on top of that, along with mycorrhizal host plants, is needing to have not using a fallow system, because it's again going back to the carbon problem. If you don't have a plant host fixing your carbon, you don't have any food. So you need to have that around. Lots of things we need to know. Glomalin, like I said, was discovered in the early 1990s. We need to know things like how to increase production, how to keep a plant happy enough to grow, but marginally happy. So, I mean, again, if you want a really, really happy plant, you give it all the fertilizer and water and everything that it needs to grow. But you want it to be kind of marginally happy so that it grows and it's nice and healthy, but that it needs microbial populations as well. So you want happy plant equals happy fungus equals more glomalin, and you want to keep that relationship going. Rangeland management is a big thing. Grazing management here in North Dakota. I just recently moved to the state, so it's something that I'm learning a lot about. It's something we know next to nothing about when we're looking at microbial populations, the effect on those soils, how that works with carbon and nitrogen storage, how that works in comparison to cropland systems. There's a lot of information out there. It's just going to take us getting our hands dirty and going out there and trying to dig it up. And on top of that, looking at some of these different aspects, I'm kind of talking a lot here about glomalin and sort of trying to strike home the point of how it's sort of this cure-all for everything. It has this sugar characteristic that helps it glue stuff together, and hydrophobic characteristic that helps to keep things stable and all of these things. There are other biomolecules out there, and I'm not saying that all of this is due to glomalin. This is one of the things that we're finding right now. It's one of the major players that's out there. But understanding how biochemistry, soil biology is related to soil formation, soil health, those are things where you need to start looking at how this whole system works together. I mean, soil chemistry is not separated from soil physics, and that's not separated from soil biology. All of these are an integrated system below ground, and we need to start paying a lot more attention to how to bring those different types of things together. So that's kind of it about the scum of the earth. Dr. Casey was kind enough to hand out the brochure, so feel free to contact me. I'm just getting started, so I can use all the help I can get. And I'm going to sort of make a plea that if any of you are interested in coming out to Mandan and working on glomalin, feel free. am more than open to having people come out and work with me, and on this winter, this summer, whatever, I can find resources, financial resources if need be. So it's just a matter of interest and your willingness to do it.
Any questions for Christine? Does
Yes.
glomalin stain in trypan blue?
I don't know. I don't think so, because we don't see it. If you do, trypan blue staining is typical for mycorrhizal fungi, fungal hyphae.
So
And we don't,
chitin,
yeah. It probably doesn't, and we don't see it, we don't see trypan blue on surrounding debris like we do with the glomalin. So I would say no.
Now, does the glomalin cover both the thick wall and thin wall hyphae, or just the thick wall?
That's an interesting question, and what we think is that because of the whole idea of carbon allocation is that it's primarily probably on the thick wall as opposed to the thin wall, because the thin wall doesn't last for very long, so you wouldn't put that much carbon energy into forming a molecule to coat hyphae that's only going to last for a week or two. But the thick-walled hyphae that's around, and that's the major conduit hyphae as well, as opposed to the finer thin-walled is more of the ephemeral stuff that goes out and picks it up. But the distance between, thin-walled and thick-walled within the soil is not as far as thin-walled to fungal, to plant roots.
And so most of the absorption will be taking place in the thin wall?
Yeah. And that as well, you wouldn't want to have this coating on there because that could inhibit some of your absorption. Yeah.
Remove glomalin, if you extract glomalin from the soil, you put it back and still have an active immune nature of the soil.
That's an interesting question, and we haven't specifically tested that. My inclination is with the way that we go about extracting it and purifying it and freeze drying it, that it's no longer going to be active. Part of that problem is, and it's one of the research projects, again, if anybody's interested in getting someone involved in this is a little bit more within the laboratory work than out in the field, is figuring out a different way to extract it. And what I'd like to do is not extract it in an aqueous solution, or to extract it in something that has a little bit more of an amphiphilic character, in order to try and keep it in that conformation that's going to have that hydrophobicity associated with it. Because by the time we get it, again, extracted, purified, and freeze-dried, we've had it change. Proteins will do folding patterns based on the solution that they're in, and we've had it change conformation so that a lot of the outside groups to the molecule are now hydrophilic as opposed to hydrophobic. And I don't know if we can put it back in and have it refold and be hydrophobic again. I would suspect not very easily.
What destroys glomalin? I mean, how does, if you break the hyphae network, does it just wither away like a leaf separated from a tree? Or what happens to it when you kill stuff?
For the most part, it doesn't get destroyed because it has a long turnover time. It eventually breaks down, as everything does. And there are probably fractions of it that break down. Some of the glomalin that maybe the Hawaii soil that it took 25 times to extract it. When we did the original measurements on carbon dating, we got carbon dating that was 7 to 42 years, and we extracted from that same soil. We only extracted it 8 times before we did that carbon dating. So some of the stuff that we extracted at the 25th time was probably much older material, carbon dating wise. It probably doesn't have the same structure. And in fact, I wouldn't be surprised if it hasn't lost a lot of the sugars that are associated with it, and even some of the proteinaceous, some of the amino acid groups, because that's candy for microbes. I mean, just like us, we like having sugars better than protein, and protein better than fat. and so it's kind of the same hierarchy for microbial populations. So we have this molecule that has, sugar, protein, and fat, and it's going to eat the sugar and the protein first, and then hit the fat last. And so that's probably a lot of what we're measuring for the later stuff. As to what eats it and when it finally gets degraded, I have no idea.
related to organic carbon. And so like they're hydrophobic, so they're absorbed to other hydrophobic substances.
Right,
So
right.
how much of that fraction of organic carbon, or whatever they say, do you think is responsible for this, the boomerang part of it? How much of that boomerang part is responsible for that sort of? Do you think it's all, or part, or?
I think that it's a fairly large part. It's kind of hard for me to say for sure all of that. I think that there is an element of glomalin being important in, they look a lot at that with pesticides and organic contaminants, and I think that's glomalin probably does play a fairly large role in that, and that's what makes it difficult sometimes to measure. To look at, part of my dissertation project was to look at the structure of glomalin, molecular structure of glomalin, which I realized very quickly was next to impossible to do. And some of it is because it does have differences in the soil. And what ends up happening is that we can't get the protein, the measurable weight of protein. We can measure that by a colorimetric assay. That doesn't correlate 100% with the gravimetric weight of the molecule, which it shouldn't, and it wouldn't if it was, has glycosyl groups. When we measure glycosyl groups on there, still can't get a correlation. So there's something in the soil, and that happens differently when we extract it from pot culture. So there's something in the soil where it may be absorbing some of the organic contaminants that add a lot of weight to this molecule that we're no longer measuring by the methods that we're using to measure it.
Is there anybody doing stuff on that? Or?
Nobody's doing stuff on that. My PhD academic advisor at the University of Maryland was interested in trying to do some of that work at some point in time. But it again is, there's a lot of things that are going on there, and that's a big thing to start looking at, is the organic contaminants and binding to those alphatic molecules. So yeah, if you're interested.
Wow.
I was wondering if glomalin is produced all by other kinds of fungi. For instance, if you have a green workaround and a plow out under it or something, there's a lot of some of the decomposition there, and it wouldn't come by
Right. You're right. Your decomposers, your saprophytes, typically wouldn't produce glomalin, and it's for the same reason as we were talking about with ephemeral hyphae and fine hyphae. They're short-lived. A lot of their carbon goes into growing and then forming resistant structures to structures to survive till they get more food. So they'll form spores, or they'll put carbon into that. They put a lot of lipids and carbon into those types of things. So they don't necessarily put carbon into forming structures that coat the surface of their hyphae. There are some saprophytic fungi. Tikan Cesar is at the ARS lab in Sydney, Montana, and she's doing some work on basidiomycetes that form a compound similar to glomalin that's coating the fungal hyphae. And what she's found is that compound is not as resistant as glomalin. It doesn't last in the soil as long as glomalin does. On top of that, there is Joseph Wessels, and I'm trying to think of where he was at. He just recently retired, and he discovered something that he called hydrophobins. And they're molecules that are formed, and he found them forming on mostly fruiting bodies of fungal hyphae, so like mushrooms. When the hyphae comes to, it's an air-water interface sort of circumstance that he was looking at, that you would have on the top of mushrooms, that you would have this coating that helps to keep mushrooms from drying out, from desiccation, as well as helps with rainfall on the above-ground fruiting bodies. And he found similar type of molecule on like spores, fungal spores and fungal conidia and those types of things. So there's a lot of similar types of molecules that may be formed by different fungi. And that's one thing, again, I said, we're looking at glomalin, and that pie chart that I had up there, this is something just like humic acid being operationally defined by extraction procedure. Glomalin, for the most part, is operationally defined by extraction procedure. And there may be a lot of other things out there. And I think that it's just making you aware of some of the compounds that are contributing to soil biology, and soil biology contributing to soil structure.
How does the level of glomalin change as you go deeper into the soil?
From what we found is that the majority of it is on the surface of the soil. Within about the first 10 centimeters is mostly where we sample, and that drops off as you go further down. And a lot of that's because where the active fungal hyphae is, so your annual production of glomalin is going to be higher at those locations. Because we don't completely understand production versus accumulation, and again, in the soil that it took us 25 times to extract glomalin, there was probably a lot of that would have been at other depths as well, because the way that glomalin, and something's eating it. It has a long residence time, but there are some fractions of it that are getting eaten, some parts of the molecule that are getting degraded, and the more resistant fractions are probably increasing with depth, that you're going to get, well, maybe not increasing with depth, but the further down you get, you're probably getting those different fractions of this molecule that may be more resistant. It does. And the mycorrhizal, you can find internal colonization of mycorrhizal hyphae that will go down that far, and you would potentially have glomalin that would be there, because that glomalin is actually on, we do immunofluorescence on our buscules within roots, and we'll find glomalin on there. So when the roots that are down there, when they would degrade, the glomalins associated with that intraradical hyphae within the root hyphae would be there. But the hyphae themselves are active in the first about 10 centimeters, if not a little bit, maybe just a little bit lower than that, but where the root's going all the way down, you don't have active hyphae that's out there, so you wouldn't get active production. And as far as what would go down with soil water, I think, is an interesting problem. How much of the scum goes how far down, and more of it's going to be lost to the surface. What?
Because it's not mixing with water, it's on.
Right, it's on water.
It must be in macropore.
Yeah.
Soil transport, stuff like that.
Yeah.
Let's,
So.
I don't know, I mean to interrupt.
Yeah.
Those of you who want to get up and go, you can go, or if you want to stick around for the discussion, stick around. I know there's some students, I know we're just going beyond the time, so I don't know if people are ready to get going, they can get going, but if you want to stick around, just stick around and discuss.
Okay, thanks.
Yeah.
I've actually found a lot of external hyphae from 10 to 20 centimeters.
Okay.
I mean, almost as many from 0 to 10, at least in the soil that I'm looking at.
It's the soil that you're looking at, is it fairly porous, or is it?
It's sand
Okay,
soil.
okay. Because I think that would make a difference as far as
Now, when you-
more aerobic soil is going to have more.
and when you mentioned 500 meters of hyphae per gram, what type of soil is that in?
It's in undisturbed prairie loam, I would say. I don't know the exact soil type, can't recall it off the top of my head. Mike Miller and Julie Jastrow at Argonne National Labs in Chicago have done a lot of that work, and in his prairie soils he can find so. Glomalin. What we've found, not necessarily so much with the structure, but with amounts, is in more calcareous soils we find lesser amounts of glomalin than we find in acidic soils, more acidic soils. And the fungi don't completely follow that trend. You'll still have good prolific fungal growth in calcareous soils as well as acidic soils. So there's something that's probably going on there as far as production, and I'm not sure, what all of the mechanisms may be. What? I'm sorry. Higher pH in calcareous soils? Yeah. And you're thinking more hydrolysis at higher pH? Yeah. I mean, it could be. It could be. It probably, that's probably a lot of the case, because it's probably more of a accumulation problem than a production problem. That the production may be the same, but it accumulates in acidic soils and doesn't accumulate as well in calcareous soils. Some hydrolysis could be a factor. One of the other factors that we put it on is because it hyperaccumulates cations, and iron availability is higher in acidic soils, and that's going to help to make a more complex structure that's going to resist degradation. And so that's one of the other factors, but definitely could be a factor with hydrolysis there. Yes.
How does glomalin interact with your soil fauna, earthworms, soil insects?
I don't know. Lots I don't know. If I had to hazard a guess, I would say that it probably interacts very well in the fact that it has been around for such a long period of time, so that it's. It could be a potential food source for some microbial populations, for earthworms or microarthropods. There is a high potential, talking about some interactions, because these fungi have been known to help with disease resistance. There's a high potential that glomalin helps to coat plant roots that are where it's colonized, that would help them be resistant to attack by various pathogens, various disease organisms, insect populations. The easy answer is I don't know for sure. I can speculate by a lot of things. And as far as it being a food source, again, something's got to eat it. Columbella love to feed on mycorrhizal fungal hyphae, but we've put glomalin in a petri dish with columbella, and it doesn't do anything. So it's either because it's already extracted glomalin, and however that's interacting, we don't know. But it's hard to say.
Well, let's give Christine a
Thank you. As I said, feel free to contact me. My email and phone number and address and any contact information is on there. So, thanks.
Here's a towel just to wipe your hands, so.
A towel to wipe your face if you eat that dirt?
Yeah. And I don't know if we want to take one of these towels inside.
You should have put those worms in little shots of tequila.
What's that?
Should have put those worms in little shots of tequila.
calm the kids down.
What does it mean when that yellow thing is flashing? What's that mean?
I don't know. Battery, no tape. Okay, good.
Means the memory is full?
No, it's on a tape.
Oh, a tape.
I'll bring another tape.
Okay.
Okay. Of course, he Mark donated a bunch of bags. So they can put the stuff in the bag. How many bags they got?
What do you have for today, Nate? Oh. Yeah.
Oh, that comes out.
Is this supposed to be a laser gun or what? Don't touch. Whoa!
Whoa.
Hey guys, don't touch anything until you're told.
Guys, just try to you want to go down this way too. I didn't realize that this. My wife and I are belong to the chemical. All right, well, welcome to the Soil Science Department. My name is Frank Casey. I teach soil physics here. I've been here for about 5 years. And I always have kind of a difficult time explaining what soil science is. But I believe it's probably one of the best sciences that is out there.
And the most important.
And the most important. As you know that soils covers the earth. It's on every part of the earth. I was going to mention to you, my wife and I, I mentioned it, we belong to the Catholic Homeschool Network here in town, so we're thinking about homeschooling our kids. We only have a 4-year-old is our oldest right now, but we're considering it. So anyhow, and then Joel Bell is another individual in our department. He also has a couple of kids here in this group. So what I did here was we just brought out different things that we work with as a science. We work. The thing I like about it is that we work in the field when we want to work in the field, doing soil sampling or studying water movement or how agriculture impacts the environment or how industry impacts the environment or different things. We talk about fertility and production, so we're in the field. And then we also do stuff in the laboratory, and we can work with beakers and tubes and doing genetics and studying biology of the soil. And then we also do stuff on computers, and we do modeling, and we do a lot of stuff with computers. I myself spend most of my day in front of a computer. So there's a variety of different things that we can occupy ourselves with, but then also if you're interested in whatever science, biology, who here is interested in biology? Kids? You guys don't like biology? Okay. Chemistry, like how kids chemistry. You guys interested in chemistry? Physics, which is like the movement of stuff, how things like that, the stars, the planets, stuff like that. Earth sciences, geology, those types of things. Well, you can combine all those things in soil science. You have the ability to apply your biology. If you're interested in biology, then you can go into soil science and actually apply it. My sister is a PhD in microbiology, and she sits there with a pipette all day, you know? And I'm like, how do you do it? And, you know, if you're gonna be a biologist, apply it, you know, go out into the field and use it that way. So that's what I really like about soils, like you get your hands dirty. We also have in our department the state climatologist, John Enns, and he has this weather network throughout the state where we collect weather data. Radu Karena is his technician and has set up some weather instrumentation here, manometers, that they get wind speed. They set up weather stations throughout the state where they can use solar energy to collect the data, and then you can use telephone to access it. We also have Keith Anderson. He's belongs to the SCS. So no, what's your? It's
NRS. NR, formerly Soil Conservation Service.
Yeah. And they do a lot with mapping of soils, so going out to the field and taking soil cores, using instruments like this and digging holes to determine what types of soils there are in different locations to see, you know, yeah, sure. Okay, what this is out of here, we have the dip, and the water comes through here. And this, and what we do is we measure how long the water is. And this tells us about whether the soil can, like let's say for example there's a flood, and whether the water can go into the soil easily or not.
So we have to know how many in.
Okay.
Okay, we just had a visit from the homeschooled kindergarten through third grade. The next group are from the, they're also homeschooled, fourth grade all the way up through 12th grade. Mostly they'll be fourth grade through, I believe, 8th grade. Thank you.
Mm-hmm.
What I do, I'm a soil scientist, I'm a soil physicist. I study water movement, chemical transport through soils, and soil science is, like I said, a hard thing to describe what we do. So what we've done here is we just set out different things that touch a little bit on what we do in soil science. So we laid out some of the instrumentation that we use, and this is, you know, probably 1/10 of what we do. It's just hitting the surface. The one thing that I really enjoy is you have an opportunity to work in the field, so you have an opportunity to go outside with soil science. You have an opportunity to do stuff in the laboratory, to work on, you know, if you do experiments in laboratory that you really enjoy, working with balances, doing biology, physics, chemistry in the laboratory, and then also have opportunities to work on the computer, doing modeling, all sorts of spreadsheet, writing, stuff like that. So there's opportunities to do things in different environments, but then there's also different subjects that you can cover. So who here has interest in biology? Do any of you guys have interest in biology? How about like math? I'm going to cover everything, so you know, you guys got to raise your hand for something. Math, there's some interest in math. Chemistry, physics. So nobody. It's just not cool to like those things, I guess. But I mean, these are the different things. I mean, there's different majors you can take. You take a major in chemistry, physics, math individually, but in soil science you can apply all these things at once. That's the beauty of soils, is that
if you're interested in one of these things, you really get to apply yourself to one of these different fields and apply it to soil science. And then also, like for example, I was talking about my sister earlier. She has bad mouth in her. She's a PhD in biology, and for example, what she does is she sits in the lab and she uses a pipette all day, you know, doing her biology stuff. But in soil science, you actually get to apply that. You actually go out in the field and you apply your knowledge as a biologist, or you can use that knowledge in the laboratory. I was going to mention, there's a couple guys, you guys are homeschool groups. There's Joe Bell is a homeschooler, he's in our department. And myself, my wife and I belong to the Catholic Homeschool Network here in Park. So I'm encouraged to see a lot of you guys here today. And what I also want to do is give you guys an opportunity to just go around and looking at the different things that we do. Hands-on, you guys can touch whatever you want. Some of these individuals will help you with some of the displays, so go ahead, touch what you want, look at things, and ask questions of the different individuals here. There's also a video over there that just shows some pictures, gives you an idea of some of the things that we do, but we really encourage you guys to ask any questions that you have about soil science. So, thank you. This is, for example, what's that? Oh yeah, there's one more thing I want to. This is the sun. Okay. I want to say something here. If I do, hold on. There's a packet here. I want you guys to pick up. This also kind of is a poster. It explains a little bit visually of some of the different fields that we get into, some of the different types of research that we do. We also have some comments from our graduates who work in different areas. They own consulting companies, they work at universities, they work at NASA. I mean, we've got a variety of different people that do different things. We use this thing right here for doing remote sensing. We took pictures, we rigged it up with a camera, so we do some remote sensing of crops. So go ahead and just poke around. You guys can play around with this thing, touch the aileron, make visit. You can see the aileron moving around. So grab one of these things for you guys. Night crawlers. For you, you're not moving it. Yeah. This. And you go like that. Put that chair. Any questions? This is we use it to take book words. There's actually there's a reason here put it into the center like this as a board. We can get different information about how water moves through the soil. So different types of soil have different properties of how water moves through that. So that dictates stuff such as like how let's be in the area to flying this is another thing that one is water. Well,
Or the real things. all over campus today? Is this the last talk? So some of us are soil mold. So this is what we get to do. We get to some changes to a lot of like cutting area soils and take a weak acid and quite often soils are checked for reactions
like large
reaction of acid in the base
whether that we use to characterize so for example here we shake it down a larger particles are taken up here the medium size or in these size probes that we can take soil samples
really striking about this
characterize with technical whether or not it's good for building on or whether or not it's good for farmland.
Soil more
this is an issue
local
to measure how the water this is soil, how the weeds are
western Minnesota, so this is about 50 miles away, but it's definitely different than something about 10 miles
versus a clay
west of here. So these profiles are about 50 miles apart.
These what type of soils
One thing when I moved up here,
you pass that around
you know, back where I'm from, it's all flat, brown, light.
But in this one, the
Really does
infiltration is
brown.
better than
It's the organic matter compost. I mean, the more organic the better, the likely it is.
Makes me wonder why there's no up here in the northern cities that are not in Illinois where I'm from.
The climate is more conducive to building up that we get so it doesn't get
I know where I'm from, it's hot and humid, so our earth is really dry.
you get warmer temperatures this form under grassland in Illinois probably was originally more like and that's more soils are browner. And the prairie soils are also well, yeah, but black like this is more fertile too. So it's a lot more nutrients. Just doesn't like good things. Yeah, we do.
our oldest is working with stuff. Not full-fledged.
They have more rain, so they can still grow good crops. But we can grow good crops with less rain because our soil is sometimes they dig them out and they glue on or something so that you can stand it up on display. There you go. This one is called Glendon. This one is called Chapel. So we have the opportunity to find the soil and name it whatever we want. So we typically name them after towns like Fargo, Kendrick.
We fly it out. We fly it out always.
Is this really underneath?
Did you guys get this? You did? Did you get this?
It's like on here.
Probably, sometimes it's chunkier. Sometimes it is more broken up, but the soils, not only is it different here, but quite often it's different. Like this is a soil that was, this material was much corrupted by like water. There's like 5 things that have to be the material that you start with, the length of time that it's been there, the
And so that was part of
perfect thing to have it for some artificial soil and stuff like that. Ground up what other departments did you visit?
But we went to that guy. What was that? Oh
It's
I think it's from 2 years of working with this. Resulted in
What's those guys up
Thanks for coming by. Take care.
Thank you very much, guys.
Visit our soil science webpage on NDSU. Yeah.
Hey, grab me a purple one.
It's like horse feet. Basically. Yeah, horse feet. No, it's not. Milk, sugar, honey. Oh,
that's still running.
It needs some you know, I don't know. Oh, here we go. Would you guys mind giving up that brown bag for the,
Oh, yeah.
But we took the gummy worm out.
We're all gone.
Why don't you get a picture of the group?
Outside, yes, not the entry.
Yeah, we said.
Here it comes.
Okay, all right, we'll be there.
From above. Bali came from.
Bali is right out there. Bali is the one that ends in this cul-de-sac and goes north and south, right out there.
Okay, and then Centennial's one that. Oh, yeah?
Right there.
I'll be there. Not red.
Hey, show them.
Did you get your class next semester?
No, I didn't. I'm grouping my classes on Tuesdays and Thursdays next semester, so.
Oh, yeah.
No.
We'll leave for trying.
He keeps running and digging into, there's something down there. He grabs some, just like a little tweet.
And then you pack 10, 12 people in there and they all fall out again. They didn't even think about it. No. Pile the luggage and then this guy going through a hundred lifts. 35 presents.
You got it. Hey. Wild rice, chicken, roll, and those different types. Besides a whole food buffet.
No, that was a 5-year deal.
Sorry to keep you waiting, Radu.
Yeah. Well, thanks the camera. Next one. Hello. I got you. Yeah. Somebody's supposed to.
Hey, Frank. Hey! Hey, Carl.
Hey,
Happy New Year.
Oh, yeah.
This is the lady?
Happy New Year, Doc.
Thank you. We'll take care of it. Take care of
Sharon? 41 chair. What is this?
This is me
So what is it?
Lane got it here. Is that last Friday? Not last Friday.
I had to get a new one. Isn't this beautiful? He likes it. The chef likes it. It's you. I just got a grip. Well, Happy New Year, everybody, and welcome to our annual department get-together. Louis Price. Yeah, I think we'll start some of these and run some of these through first. Your number, whatever your number is, hang on to your drawing number. That's what will match up. Here, it's not good. And you can trade, everybody can trade, doesn't matter. So whoever's got number 18, 1-8. And they're all out, so some number's going to be around somewhere. You can't hide. 1-8. Come on, 18. There he is. Dr. Ennis. There's the camera. 23. Who's 23? Well, it's black and orange. I don't know what it is. They said you were supposed to say what it is, but I don't know what it is. With orange shirt.
Somebody wants to pick on your type of thing. So we didn't know that was 4 or 5 years.
Number 10.
Box like this, it's a printing machine for light and light.
It's not 01. Come on. Computer geek. All right, that's what you need, a back massager. Right here you go. 13. Do not use this bag. It's not a toy.
Wholesalers that provide
Someone want to pass this to the raise.
Thank you. Very wisely.
Number 4. Sharon's got a blue one. Well, a quilting tote bag is what it is. Quilting bag? Yep. Who's got number 11? Everybody knows this bowl. Joel got Joel! That's the salsa bowl. That's the salsa bowl. That's the salsa bowl from the coffee room. It's been laying around for too much.
What are we going to put sauce in here?
We'll talk Joel into leaving in the coffee room.
We need that coffee room ashtray.
Okay, number 30. Reserve another back massager. Grad students need those. There you go. Watch it. Now we should make an announcement if anybody knows where the bag of decorations from previous years are. Anyone that's seen them anywhere stored, look around. We can't find it. That had our original hats and all the department decorations in it. So we didn't have the elf ears and the Santa hat this year. Well, we got a special gift here that didn't come across our desk. Sharon, come up here.
I didn't do anything wrong.
You don't have to do things. Are you enjoying yourself today? We just got to our desk by mistake. And actually, Joel Bell received this. So this is something you can open up.
Is there a balloon or something?
No.
Snake that's going to pop.
This is a piece. This is was supposed to go to a piece of software that you're supposed to receive.
PeopleSoft?
Yeah, this is PeopleSoft, yes. Yep, PeopleSoft software here. This is supposed to come in your packet. And what they were supposed to send you were as a safety officer, these are, they're a safe thing. PeopleSoft software stress balls. One for each hand.
Repeating squeezing relieves stress. 2 included, 1 for each hand. Safe for use on computer monitors and most other surfaces. Bright, cheerful color, not tested on animals, and safe for the environment.
I made the mistake yesterday. I was doing that. That's how it was going. And I had 2 people holler at me simultaneously. I left quick. Oh, okay. Yeah, let's do 4 more. We gotta start these out.
Really stupid.
35. Number 35 is a case. All right. Oh, yeah. Number, is this a 6 or a 9? We didn't underline it.
Oh, the next one will be the other one.
Yeah. Let's call this one 9, and the next one will be 6.
You got 9 there?
Yeah.
Okay, I got 6 here. Then.
Okay. Let's get them out of the way right away.
Nice clock.
And yeah, what Dave, is that camera?
Yes.
Digital camera. These are all thanks to our office staff for ordering all good things. They come from Quill, most of them, right? Or all of them? More we keep using supplies, the more freebies we get. You pay for it one way or another. Sure.
Number 1.
Numero uno.
one. There you go.
Hey, just what he needs.
Backpack, let's say.
Okay. Well, let's see. One of these recipients isn't here, but the other one is. Dr. Goose.
I didn't do anything bad this year.
But this is supposed to be for Franzen and Goose, but Dr. Franzen's not here. Earlier here? In the department today?
No, he wasn't in today.
So he faked out, I don't know, a leak out or...
Yeah, but Jay will do.
Anyway, Jay will do. Now, it came to our attention that a couple months ago, Dave and Jay had to go on a trip.
He was driving.
On an extension trip.
I was just sitting. You're navigator.
You're designated navigator. And apparently they got loaded up to go on this extension trip, started off, and didn't know how to go where they were going. So they had to call back to the office and ask, how do we get to where we're going? And they were only going to Morris, Minnesota. I mean, Highway 75, and you run into Morris. I mean, come on. So now we got you your own personal GPS units. Great personal secretaries. GPS. This one's for Jay. Help number, Pam. Campus directory, if you really don't know anybody else. Morris, Highway 75, south. Return to Fargo, Highway 75, north. So we have one for Dave too. So this is your own GPS unit. Carry it with you always. It will get you where you need to go. Well, Dave, or either that or, boy, see, here's Dave's, but it's got Marilyn and Pam's number in it.
So it's customized. Huh?
Customized, personalized GPS unit. You get lost going from Fargo to Morris. I don't know.
I said, which exit do we take? I don't know.
He's still trying to explain this.
Number 26. 26. Mr. Anderson. I don't know what this is. It's got batteries in it, though. Instructions are in a different way.
These things are wrapped up. I have no idea what they are. 19.
19.
Come up and get it. You can walk in front of people. We don't fight.
Give him a kung fu shit.
Number 21.
Joey
got it.
All right.
More vanilla sugar. Body lotion.
Body. is one of the things that I'm finding out. Number 17. 17. Oh, Muhammad, you get cucumber melon body lotion. Oh, we get to smell you every day for a month. Everybody smell Muhammad for a month. See what he uses it. You're digging into it to find out what they are. That's good.
This we know what they got.
Yeah.
Number 12.
Still don't know what it is.
Car.
It's stationary.
No. Oh, you get a clock for your desk so you're not late.
Hey.
All right. Done with that. Yeah, I can get that. I know.
For those that don't know, Norm got stationary one year and traded it away right away.
And number 5.
Radu.
Radu. There we go. Radu gets candles. Again, I hate them. Which is good because this is light. So there you go.
That's just like a little kid.
Suppose that we change it on our way. Okay.
Yeah, we better do it.
Frank Casey, would you please come up here? And
Mike, there you go.
Frank, I'd like you to present this.
And we'll need to pass this one around too.
Yeah, this one, I want you to present this.
And since you're advisor, Frank, turn around. Yeah. Turn around. You can read it to the crowd.
Okay, this is a certificate that certifies Michael Thompson in the recognition of outstanding service for agronomic excellence. Has been duly selected by the committee of the award to receive this certificate given at the Soil Science Recognition Banquet this 4th day of January.
And the reason it is because also the Foreign Corn Producers Association presents its 2004 Award of Achievement to Frank Xavier Casey.
Foreign corn producers.
Yes. For his comprehensive research on lowering U.S. corn yields and for painstakingly teaching his corn production practices to his graduate students. And if anybody was at Mike's seminar, you saw a pitiful picture of a corn plot that he presented.
We need to pass this around.
It's a top secret experiment.
Yeah.
They're trying to develop mini corns for the Chinese
So we will pass around this plot that Frank was responsible for his graduate student doing, and you can see what wonderful agronomic practices. You got to put that in the weeds there.
Iowa State University, by the way.
And also the North Dakota Ag Association had a limited edition 2005 crop production guide that they want presented to Frank in honor of his services to the state of North Dakota.
He needs the help.
Limited edition. Thank you, Frank.
Passing on your agronomic knowledge. Oh, number 14. A duffel.
That's what I got last year.
Well, they give a lot of those away.
Number 2. Yeah. 2. All right, a clock there. That might be that candle again.
Yeah, and number 29, that might be another Radu candle, yeah. Yeah, Yeah, I think so. A flashlight candle.
Good for fishing.
Good for fishing. 29. There you go. There's a special one.
Number 20.
Is it big enough for you?
Number 20.
Who's got number 20? All right. Rank 2.
Oh, we knew. 27. Looks like it might be a day planner in a zippered case. I'm not sure. Or a big manicure set, or something gets zippered up. Oh, sure, it's a date book. Day planner. There you go.
Number 15. Oh, Bill!
Bill!
You actually set a coffee cups here. I don't know what you're doing down there.
Okay, should we do another one? Well, see, you're gonna have to do one. Joe's gonna. Well, you know, maybe we should, maybe we'll still do Joe, but Norm will have to stand up here in his place. Since Joe's not here, today, we'll go with.
Is this like a flash?
Sure. Now, we all heard that Joe was going to retire, and everybody heard about it.
This might be rubbing off on the technician.
Yeah, I know. But you know what? Within 2 or 3 days of everybody finding out, Joe had 3 new words in his vocabulary that we had never heard for 20 years. Never heard. I don't care. And he would tell you right out, Joe, you got, I don't care. He'd say, I don't care. And since you got the bottle of seed for me, and Joe was sitting right there, you can give it back to him now. So he can put it on his desk, or he could just pull it off, wear it in his pocket. And of course, every retiree needs his I don't care billfold certificate. He can whip it out on anybody as they want. So you can give him his I don't care plaque. We had never heard Joe say that in 20 years.
Bill, you're gonna have to clean out a spot in his office though.
31.
So what are these
31. Ed! I think you, yeah, that probably fits. Another massage in there, Ed? You've been working hard at home?
33. Looks like a little rolling pilot case. Folds in half, pops up, got wheels on the bottom. 33. Where are you going? Where? Find a place.
He's got number 3. Oh, grad student needs. This is a date planner here. For all those business trips.
All those conferences that Dave's going to send you to, right? Number 22. Oh, you can sit in the greenhouse and listen to his little radio. Over the roar of the fan. Thanks a lot. This is it. Chris.
All the feds. Which wrong thing are we?
Now, those two over here, we need Chief first.
You are the leader of this. And as such leader, you're supposed to train your staff once they get into this area.
There's been a slight dereliction of duty.
I believe so.
You haven't done a very good job.
What happened to you on the first day of snow this year? What kind of accident?
Supervisor didn't train him.
That's wrong accident. It's
What'd you hit then?
The concrete glass in the house.
How many times? Oh! Keep giving you instruction on driving the ice or snow at all?
Until the next day.
Kind of shut the barn door a little late there, aren't you?
So what we did find for you was the official NRCS winter driving instruction kit. And you need to go over this information with your staff. I mean, there is really the rules of the road in North Dakota. There's a website for the Teenage Driving School. And so you can check out this website and teach them. And there's tire grip. Tire driving. And then FEMA, which is another federal agency, which you probably didn't even research on, has a hazards fact sheet for winter driving. There's all sorts of information on winter driving in North Dakota, Washington State, NOAA, Bismarck. And so we would like you to please go over this as staff. There's a kit for each one of your personnel here.
You've been very thorough.
Yes.
It's all goes under training time, so you have a coach for that.
Lock in and realize they're watching.
They're watching.
We'd like to thank you, and hopefully you can teach fellow drivers. There are empty parking lots. We'll practice at AR lot. The AR lot? Thank you.
34. Another rolling double. You and Larry taking off on a weekend a secret weekend around these can't say more.
24. 2-4. Here's another little travel kit. What's going on down there? That table?
Whoa! All three of them are going.
We thought we were eliminated.
Taking the show on the road. Number 7. Fan. Probably the only one who'll figure this out. It's a little computer gizmo with an earphone. That's out of my league, let me tell you. Oh, I would wait for this one too.
Yeah. Number 8.
Aromatherapy. For free, you get together with Mohammed.
Experiment vanilla olive.
Oh, you have to take that home.
Making me feel happy.
You'll have to try that and find out.
You still have diapers.
Number 30.
Yeah.
32. Jake Pride, are you working Jay Hart?
I don't know.
Oh, is this one of these back?
This is one of the massagers, yes.
Oh my goodness. Yeah. Yeah, he's been real tense lately.
Yes, he has. Well, we gotta go with Swenson.
Yeah, here's another duffel. Who's going with Swenson here? 16. I knew who blushed right away. I didn't even have to say here. Oh, last but not least, huh?
Okay, what's another guy?
Yeah, who hasn't come up here? It's got to be you, the last one here. Number 25. Who's got a number? All right.
Got some pieces of papers to shred? Is that what it is?
This must be
Paper shredder, there you go.
Straighten my clock.
Well, I don't know, department. Does anybody else deserve an award this year? Who do you think deserves an award this year? Again. Larry. Huh? I don't even have to say a name. Everybody's pointing. Everybody's just pointing. But you should turn around and see the room. They're doing this number.
I thank Bill for finding my keys underneath the water cooler. Turn on it.
You think that's all? You really think that's all?
Okay.
You know, you even passed Hopkins. He is such a target every year, but you're right up there all the time, aren't you? Well, the first one came to our attention, and everybody, I mean our attention, everybody's, that you left your credit cards and things laying on a registration desk at a hotel and went off.
step by step, kind of. Okay. That's why I'm calling. You see, it's good for every spring, every start of the season. Yeah. To check this ray gauge to be level. Oh, okay. And this way, which is parallel to this. Yeah. This is the way it is measured. You know this thing? It's a funnel there that if the water goes here from rain, and when this is full, it dumps down because it has a flow in the bottom, and fills this one. Here it's a switch on the side, here it's a magnet. You see this switch is connected with this wire, and the computer records how many impulses, how many times went magnet in front of the switch, and that's a hundreds of minutes. So, but we have to make sure that this is horizontal, you know. That has to be done every spring, because otherwise, this is a funnel, you know, and sometime maybe here it's pasture, maybe clean up where it's next to field and harvest. This is full of chaff and stuff. And I have a kind of a ring that keeps this in here. This is this ring, this is a steel ring. So just take it out, and then take this out, and look to see if it's clean. just like this. And then you look at, take it out, take it clean up, and look at if it's clean, and that's all. And then I'll bury this thing, and I'll put some tubing, because if rodents are coming, they start chewing, they chew the tubing, and they leave it and play. We have trouble like that. Yeah, we have trouble like that. I found out that since I put that tubing in the spindle, you know that little tubing that you usually use in auto
still recording.
socket barb, small one, 4 inches. because I don't know how, what's the position.
For what?
This is yours?
No, that's from John in case we had to do something barbed wire.
They found here two washers. Two washer in the nut, but I think it's not that nut. See, this will be where we put the clamp, so that one down is supposed to be tight. You know, have to look for a big box. that are on the same size. Clamp, you see on this side right there where you get smoke? No, inside here in the back, but on the other side of the truck. That thing where I have the marker says paint and there are brackets. Yeah, yeah, hose clamp.
Yeah, he's kind of used to working on pieces. I'm just
You mean the devil network?
Yeah.
Example from
Yeah, the samples we took was small. It's pretty case. I like it.
Hello, today? You came back for a week? Taking your chances.
Do enough of it, you know.
Yeah, no. You came back from last year. You tried it last year too. You Yeah, that's yours. You made it last year. Just remember. Escaping. That's right. That's right. I remember that one. So you, oh, is that you? Are you isolating yourselves down there? The Hopkins group, you know? Yeah, they're just staying over there by themselves to make a video. Oh, that's right.
It's just totally offensive. Your face here.
Well, I've learned that being a babysitter is not the easiest job. Mainly my 2-year-old.
Maybe I'll make it over here.
Oh, yeah, that's a handsome. He and I went to play last week. It's just a small shop, a miniature one. He and I worked on getting a trail to the cabin for about 45 minutes. He did a wonderful job for 2-year-old. They have a studio. They have a shed. And sort of be surprised during the long time. You can sit next to us. The door opens to shut.
Well, good.
You're right-handed.
It's the right-handed. They're flapping their.
They're all, yeah, they
Us left-handers.
Yes, right.
What about you?
Who is obviously missing?
Your husband?
No.
Well, water is open and there's open doors.
Nobody's here from here. Nobody sit here. If you want to sit here, you're enjoying your rest. Would you rather sit next to the Would you rather sit next to Dr.
He said he's thinking of that wasn't working. How I feel about some drinking basic and I'll still rather buy it. I'm
Laura. Jess, all right, nice to meet you. Yeah. And I met Fine. Hi. What percent's camera chocolate?
2%.
Over 3. Laura, over 7.
Down the line. We'd like to thank you all for coming for the Christmas party. There was 10 going around. Please take a number out of that. I don't know the announcements.
No other announcements?
Well, we got, again this year, we have some specialty gifts. And
then we have the general gifts.
So what we'll do is we'll start with a specialty one. These are usually gifts that, if you haven't been here before, of people that are well deserving of something special. They've done something great for the Department of Soil Science or the NDSU campus. So first of all, we'd like to have Dr. Francis, you can step up here. Sure.
At least I don't have that anxious voice.
No, you can get over right away. Get it over with, right? Dr. Franson keeps up on his literature, his written material, and we were shocked and surprised of what happened to you while you're out on the road. I couldn't imagine something like that happen. I mean, Chad calls me up, you guys got to do something for this guy, you know. He's out on the road, he comes back with a big shiner, a big black eye. And what happened on that day, anyhow?
I don't remember any of it.
You don't remember any of that? It just happened that fast. Well, I believe you, while you were getting ready for the meetings, you kind of slipped and hit your head on the stool, it was?
Oh, that was it.
Oh, yeah. And so we got a shower cap for you to help you out. And so it wouldn't happen, you know, next time, when you take a shower, oh, this will fit, boys, you know, get the shower head, and some safety goggles, and I hit your face, and show those guys there.
Search for roller derby too. How do you guys remember all this?
Well, let's see. We've got 40 people here. We better do some of these.
What we're going to do is we'll just pick a random prize. If you have that number, please come up and
we'll just hand it to you.
Pick your gift up.
20. Who's got 20?
20? Hey, you're going to hand it.
And we have no idea what these are, so you'll have to open it and show us.
Yeah, what are those anyhow?
We've got about 4 of them. We don't know what they are. We never open them.
Okay, 38.
Pam?
Oh!
Can you get just a little, okay.
Oh, small.
Oh, the small, the little ones, those are the best ones.
It's an umbrella.
18. What age?
Flashlight. She got
The line came for Dr. Danke.
The swap meet starts at the end of the program. Number 12.
Well,
anybody got 12?
Oh, we got one in the corner here.
You got it.
Who's got 12?
12, okay. Speed up.
A CD player? What was that, Cesar?
It's a light.
Oh, flashlight.
Okay, cool.
With an emergency flasher and everything. Oh, Norman. Where's Norm?
Norm, come on up here, by golly.
He hung his head.
What could I possibly do?
Nothing.
Now, what was that story that you denied so vehemently? Sydney, Montana last spring. How did that go?
You blamed it on some basketball
Yeah.
players, I thought. There's some
Here,
basketball teams in the motel, is that what it was?
Joel's last hurrah.
Norm goes to Sydney, he comes back, turns in his voucher, didn't look at it, goes to Crystal Sugar. The bookkeeper noticed a discrepancy on the bill that he turned in of 2 nights of massage service. $50 a night.
Which is a lot of
In Sydney, Montana. In Sydney, Montana.
We thought, we believed you that it was just a basketball.
And the bookkeeper talked to the VP, and he looked at it, didn't believe it, but he signed off on it anyway. And then later he asked Norm if he had a good time. And Norm denied all this. So they thought it was the basketball team or the wrestling team or whatever was in the motel that night, threw it on his bill.
But what really happened?
But, and we took your word for it all this time. But now, just recently, we intercepted a piece of mail. We intercepted a piece of mail.
Remembering it.
And your name on it. Look at this.
Norman, yeah.
Normie.
Sealing.
I took the liberty of opening it.
Oh, yeah.
Ooh, and a note. Lipstick on the note. Female handwriting. And it says,
Why don't you read it?
a note from Bambi. I'll read this. Dear Normie, can you believe it's been a whole year since we met in Sydney? Where does the time go? I heard you got in trouble because of some blunder of the hotel clerk on your receipt. I would never charge you for that massage.
Leave him alone.
There's more.
Read it faster. I'm embarrassed.
To keep you out of trouble when you come back next month, just give the clerk the attached gift certificate, and no one will be the wiser. See you then, Poopsie. I can hardly wait. Bambi.
I'm going with you.
Sin City Massage Bar. This certificate entitles you to 2 free value $50 each massages. To Normie from Bambi.
Very nice.
And she sent a little bottle of massage oil to keep you soft and smelling good.
You know, we had a new person on the trip that year.
Okay, now he's changing again.
Thank you.
We got some gifts. Number 3.
You wouldn't even need to go to Montana to go on Gale Bridge to hand out.
Number 22.
Don't forget.
22? Nobody picked 22? Well, is that your number? What's your number? No, okay. There'll be a few of those. We'll just recycle them next year.
25? 25?
2. 2. Oh, I'm 0 for 2 here. Ooh, 26. Right here. Larry. 42. 42. Jasper, you have. Number 10. Want to do one more? Okay. Here we go. 15.
Oh, grad student.
Oh, there she goes for the field this year.
Field work, there you go.
Dr. Goose, you have a... Dr. Goose? Where do you go? He has his presentation.
Yeah, I have a brief to give out. As most of you know, this summer, our old friend Bob Halloway from South Australia was here. And he was doing some work with us in the greenhouse and in the field. And one day Bob was walking around the department and talking with people. And when he was done talking with people, he met Brian and I. We were going to go back to the greenhouse. And Bob was all excited. And he said, "Oh, I really enjoyed talking with that Norwegian fella, Radu." So Radu,
come on up.
Oh, come on.
Casey, do the picture.
So, and you know, I was thinking about this. How long has Radu lived up here? When did you move to Fargo, Radu?
Give me that. Okay. I'm not in my leisure time.
Well, you are now.
Still working. What happened?
So anyhow, so Bob thought you were a Norwegian, and it got me and Brian thinking that maybe it was time that our department made you an honorary Norwegian. And
Give me a name or something.
And to do this, we have the complete Norwegian starter kit to get you on your way to complete Scandinaviandom, including
They don't accept diversity.
including a certificate that says, now Radu, you know, that's not a bad Norwegian name. It's got long vowels, but we made it a little longer with a double A and a W, so it's Radu, you know, that's a little longer. And Carquana's not going to work as a last name, so it's got to be Carquanason. So this certifies that Radu Carquanason is an honorary Norwegian. Now, I already got 2 official Norwegians to sign this, Tim Amundsen and Keith Anderson. And so when we pass this around,
100% Norwegian.
any other Norwegians that are in the room are welcome to sign the certificate welcoming Radu into the world of honorary Norwegian. But we know this is a culture shock, so there is more to the Norwegian starter kit than just a certificate. We have all the information you need to enter into complete Scandinaviandom.
Like fishing and all that thing?
Yes, we have. We have Norwegian culture simplified. With such things as ski jumping, ice fishing, snus, and the Minnesota Vikings. We have Norwegian religion simplified. All Martin Luther all the time. And we have, last but not least, Norwegian food simplified, explaining the difference between lutefisk, which are dead fish, and lefse, which is something that drapes over a stick. So anyhow, but we also have, as the crowning piece of the Norwegian starter kit, something to help you eat the lefse. So we'll pass around the Norwegian starter kit for you, and
Yes, and the seal says Wolfgang. Yeah. And if there's any other Norwegians in the room that want to sign the certificate, the pen is here.
You
so,
betcha. Took me 25 years to be.
You're now an honorary Norwegian.
Thank you very much.
Number 4. To light your way, I think.
Thank you.
19. 1-9.
Here.
Test that.
Again?
What? No perfume? No cards? Number 29.
Number 2.
Yeah, do we?
It's like put them down there, recycle.
Well, I would call for number 2 before. 11. Anybody have 11?
Number 40. 40. Ed.
Looks like your body.
Okay. Who's next? Oh, Dr. Lim. What? Sure. Face the camera, smile.
I'd be smiling at the end.
You had a rougher year than most, in a way. Just coming from being a researcher to interim department chair. A thankless job, right? All the decisions, all the trials and tribulations.
Nobody signed.
Everything.
Not accepted.
So we
Nobody
need
signed.
to make your life easier. Oh no, this is a highlight. We need to make your life easier. And what's the easiest way to do that than your own personal easy button? For all those hard things you have to do, just push it.
Thank you.
Make your life easy.
Number 41.
Hey. Do I have to redeem this? Oh, wash rags.
Number 9. 9.
I think 6 or 9.
He needs a cookbook.
Oh, we'll call it. You need a cookie cookbook.
Cut down on those sweets.
Okay, number 39.
Right here.
That's probably.
Just put on there anywhere.
Get that spaced out. Yeah. Jump into here.
Oh. Valerie. Step up.
I didn't do anything.
Come on.
Let's go on to the table.
Larry will let you get by.
It's at the office. We didn't want to haul that stuff here.
Hey, this can't be from more than this year.
Oh, no, it wasn't.
No, we left off what we got last year.
At least that's our understanding.
Oh, I forgot last year.
Yeah, we left you off last year. We had a shot at you
No.
last year.
You went to some meetings?
I thought you adjourned.
Marilyn?
You went to some meetings, didn't you?
Yeah.
Did you have any trouble in the airport at all, or?
No.
No?
No.
You didn't? Well, we got something from the airport authority that you might have some problems. I believe you, forgot to tag luggage? Is that in Minneapolis? Oh, yes! Marilyn,
And you might have been.
Valerie had trouble with her luggage in the airport, so they called her down, and you almost didn't make the flight. And so then the airport authority in Minneapolis sent us a kit to help you out. And so what we had for you here, Valerie, so you don't forget your luggage, we got a little backpack for you. Pop that sucker on there. And it goes all the way around.
Sure it's big enough?
Oh, yeah. Oh, you don't need that.
my kids in here?
No, you don't.
No, you don't need that.
You don't need that.
But they also sent some extra stuff along here for you. Pop that sign up there.
The last time you guys put a sign up.
You gotta realize the Minnesota people sent this, so they probably didn't get the spelling quite right. But when you go to meetings, you always gotta wear those little dummy things that say where you're from and
I'm Val.
And so we thought you could just kind of go through the airport with this here, and it'd help you on the airplane so you wouldn't get Okay, there you go.
I better sign this. I better sign this.
Still isn't going to help her recognize field corn from sweet corn.
Well, we couldn't do that. You know, it's only this year's stuff here. Otherwise,
that's the one we forgot from last year.
Yeah.
But there was more than just one person in that one.
Number one.
No.
Anybody got number one?
We've already seen it. Yeah.
Number one?
Okay.
Okay, number one. Try that one. 14.
14.
14, George.
All right, Jake.
Whoa, looky there.
George Foreman.
George Foreman. How do you feel Foreman? All right, Jake. 16.
Thank you, sir.
All right, well, let's see. What's next on the
Stainless
list?
steel, even, John.
Oh,
Yeah. Hey, Marilyn, you want to come up here since
Yes, she does.
and you were just gloating. It's you, not me, you said. Oh, my.
Okay.
You never know, Marilyn. You never know.
Step right through here.
Now, we heard that you have trouble commuting to work here and that.
This way.
You've had some trouble commuting to North Fargo from Minnesota all the time, you know?
Way North Fargo.
And we heard you maybe hit a couple deer. Well, you probably don't realize this, but the Minnesota Department of Transportation has special stickers for people who hit their deer. And they do that because they got to keep track of it all. And you know, you're like a fighter pilot going to work, a bomber. And so you can stick these on your car. They're specially made deer stickers every time. Now, these are designed for the buck, the doe, and the bambies. So when you hit that little fawn, you put a little one on. There's your doe stickers, there's your buck stickers.
And you can line them up on the front.
Yeah.
And you can line it up on your front fender. You'll be proud of your deer kills.
So try and miss the deer when he comes to work. Thanks, Marilyn.
Thank you.
Okay, 35. 35. No 35?
32.
Yay, me!
Okay.
I don't know what it is. You'll have to find it.
46. 46. 46.
46.
There you go.
Hey.
Okay.
And I remembered.
23.
Hey, what was that? What was that?
There you go. Yeah, that's the
Dr. Laura. More like
Dr. Laura.
There you go. All right, there you go.
Thanks,
Hey.
I was no one.
21.
21.
2-1. Oh, it's appropriate. It's a pair of binoculars, Dave.
That's all right. And 33. 33 is yours? Okay.
Let's see. 5.
Okay, we might as well do there. And then we'll clean up. Sure.
Dr. Hopkins, would you please step on?
Everybody holds their breath.
The tension rises.
What do we
got going for me this year,
Now,
guys?
we heard you're cleaning your office up.
Yeah.
Well, cleaning your office up, you lost the book.
I want that easy button.
You lost the book on how to organize your life.
Well, I lost it long
You
ago.
lost your book. But we found it for you. But we didn't realize it was a personalized copy. And it's a personalized copy made especially for Dave on how to organize in spite of yourself.
Very good.
And there's things in here like Dave's office door before and after.
What it should look like.
The chair with holes in it and the chairs after.
This is not before and after. This is what it is and what it should be. This is not before and after. There's a difference.
You know, like your mouse pad and what it should look like, Dave?
I like this is the best one.
A pile of junk and maybe a clean file That is your office too, isn't it?
That is his office.
This is fresh print here, I'll tell you that. This is fresh. And there's a little discussion on how to clean your office.
Everything needs a place.
But what we finally want to do now, there's a sequel to this book, and how to get organized without resorting to arson. We'll go to that. But there's also a
also the Cliff Note version that you can take with you all the time. You need this, Dave. How to get organized. You need this. Everything is in here you can write up, but one of the more important things is a spare key holder with the one that goes with him in his pocket. Right, guys?
Yeah.
Right?
Was it Devil's Lake? Who to drive up?
Who had to drive and deliver a key to Dave?
I'm being framed.
And it comes with a handy belt clip.
Very good.
Where's your belt?
We'll have to work that out.
So now, you need to get organized.
What? This is a crappy. What you keep going? Coffee's in a better spot. There we go. Good to go.
You can't operate a belt clip?
I think I got it.
Here you go.
I like this.
Pass it around. Yep. 31. Over here.
37?
That's my recommendation. Mine's that fill with it.
28?
Oh, yeah. 13. Yeah.
It's ticking.
30.
43. 47. Anybody else didn't bring it? You didn't draw a number? Did anybody have a number that didn't get some? Joel. Bruce? Where'd they go? I did. Was that extra little bag? Ah. Here we go. The extra little bag. That's times 36. Here.
44.
17.
Carl?
Yep.
44.
9. 9. We'll call it a 9. We gave the 6 away. 8.
45.
How about 7?
Radu's got 7.
Radu's got 7. Here.
You think this is
I knew it was great.
Thank you.
24. Here. 24. All in a day's work.
Don't give it to the fifth.
Yeah. 27. 27? 8. We called 8. That didn't go anywhere. So
Everybody get something.
and so this one should have 34.
34.
A tisket.
Wasn't worth it. You got the basket.
Now everybody should have something. We've had more stuff.
Or maybe.
Burn.
Oh, Vern wasn't.
Well, if you come in late,
Vern,
Vern, get number 1 then.
Okay.
Okay?
Good.
So that about wraps it up. What do you think of one of these things?
Oh, they're a great time.
Laura, what do you think of these?
This is great, yeah.
You want to come up?
What did you say about me? I had a chance to do it.
Oh, you'd be surprised.
I didn't even know it.
You didn't even know it. Well, you're kind of the new kid on the block. You're the new kid on the block. That's right.
It's like a babe in the woods.
Yeah. Now, because you're the new kid on the block, and last week you made mention. You said, do y'all wear those big high hat field caps with all the mesh in the back?
A lot like you're wearing right now.
Yeah. And she called them those butt ugly things. She now has a soil science
Butt ugly hat.
and a butt ugly hat.
I won't even.
You must be careful what you say.
Oh, just wait.
And you're not done. No. Now, because you are the newest member of the faculty, in Essentia Baby in the Woods, and in the Sugar Beet Project, you have your own sugar baby. And take that, and notice the red hair. You can thank Sharon for this. She had a wonderful time making that. She's not here today, she's sick.
Oh my, that
With your own little crystal sugar pen.
diaper.
So you have your...
Can you hold it up to see?
The newest sugar baby, yes.
Do I get time off for this? For maternity. Thank you.
That does it, does it?
Oh my God.
Can make noise too.
Oh, that is lovely.
I like the hair, that's good.
Yeah. Sharon thought that was the great touch.
I don't know. I'm totally impressed.
Yeah, I see that. Well, it's good. Don't make it public.
You know, it sounds bad as it's not as bad for
I didn't even see what mine said.
This is an antique. This is a collector's item. This one has been out of print for 15, 20 years now.
This is a classic here too.
That's the newest one.
Oh, this is. How true is it? Like today, you didn't see it. That's nice.
Oh, yeah, absolutely.
I won't mess it up. I know.
Oh, that you won't mess it up. We need it. Randy, get another. This is a good one. Get a picture of this one.
Another touch of class here.
Now put it on the website so our folks can see it. All her friends can get on her website and say, what's Laura doing here with it?
Good God.
So, Chris, how come the fence got it all of the days work at? Not sure what that is.
All the days.
They said, how come the fence got it all of the days work? I'll tell you later.
The book he's got, all in the day's work, he says, how come the fence got that? I guess they gotta learn something.
They gotta learn somewhere.
Chris might trade you the cookbook for the loot box.
Has the swap meet started yet? No, they'll come.
Thanks again, everybody, for coming.
Thanks, Rod. Hopefully we'll have more.
They didn't find out.
Happy New Year.
You got one of these things, Jim?
I couldn't believe it. I said, "Where's that guy? I haven't seen you, I guess." You drew a lot. Yeah, that party over there.
After Thanksgiving.
See you again, guys. Stop in sometime, okay?
I see you all the time.
He's been a long time on the basketball court.
Yeah, I know. I gotta stop that. How's that?
How to navigate a little bit through the website, what you can find there, how that thing will apply to your specific project, business, wherever you are. Here there are two pictures, general pictures. One of them is more artistic with the sun behind. The other one is from Crosby. I been there when some contract harvester just came and started harvesting that field behind there, and I thought it's a nice picture to have as a background for our station. It was last summer taken. This is how the North Dakota map shows. As a circle, it's big, the station is in the center, and we consider that the information the station collects, it's true for 20 miles radius, and that circle assumably has 20 miles radius. So that's how it shows us the coverage and the weak spots that we have. As you can see, the blue ones are NDSUs, the other one are sponsored, and the red one we didn't have sponsored, but we just got 2 weeks ago a phone call from a business in Bismarck who will sponsor all 3 of them. Sponsored, we have to define these terms because one of these stations that you've seen before cost to buy it and install it cost about $6,000, $6,500, plus the phone line to be installed to that station, that it's extra, depend on the phone company and the distance from whatever they have to do to dig the line and all that thing. So that's initial investment in one station like that, and then it works automatically. It's powered by solar power and has a battery for nighttime. At nighttime, federal grant will support calling every of these 68 stations every night. It's called a long distance phone call, and download all the data that the station, computer in the station stored for 24 hours. So between 1 in the morning and 3 in the morning, the stations are called one by one. And if somehow one of them doesn't answer, so we'll call it again at the end of the cycle. And this phone, long distance phone call is not, it's covered by the federal grant that we participate into that project. The other expenses that, we'll go to the expenses later, but I'm just presenting now what the network consists of. And what this station does, it measures, this picture is from Carrington. It measures the wind speed. It measures the wind speed every 5 seconds. It makes an average every hour, and from there every day and every month, and whatever you ask the computer to do it for you. The wind direction measures the solar radiation, air temperature, relative humidity, soil temperature in 10 centimeters or 4-inch deep. We have a sensor 4-inch deep in the soil, so you know what the temperature is there. Rainfall and barometric pressure. And the sensors are located kind of like that. The rain gauge is not in a picture because then the station would have been smaller and so on. So practically that's where the sensors are. And soil temperature, we have two, it's square meter or yard square of bare soil and turf soil, and we have temperature 4-inch deep under both to be compared for some other purposes. Now these temperatures are read every minute, except the wind speed and wind direction, which is every 5 seconds. Every minute it's collected, read all these sensors, and made an average for every hour. So we have hourly, and it's called summarized. So the weather variables that the station record are summarized. So there are 3 kinds of data that you can find on the web. It's what the station records, what it's summarized, and then what it's calculated out of these summaries. So we have daily maximum and mean temperature, average and max wind speed, average bare and turf temperature, solar radiation, and some other calculated variables who are dew point temperature, potential evapotranspiration, degree days, crop growing stage, insect development, crop water use. All these are on the website, and that's practically what I'm here now to show you how to get there, to feel more comfortable and use this website because it's free. And many people, I found at different shows I've been, they take our free data and they embellish it a little bit, put it on a disk and sell it to people who don't know. The weather variable calculated and so are presented in form of tables. So you can choose on a website, I want a table with numbers every hour or every day, or I want a map to show me, I'll show you later what type of maps are, or graphs to see the graph going up and down, the temperature or the humidity, or in comparison with whatever period of time you select. It's explained what current data is. Current data is not in end-on language, it's yesterday data. Some other network like that is giving you right now or last week or something. As I told you before, every night the computer calls all stations and download data. So what you find on a website is yesterday data. From midnight to midnight, that means yesterday. And I talked with some of you that calls the station in summertime twice a day or so to see the wind speed, the direction, for spraying purposes mostly. Because this information are stored, and in case of litigations and so, the lawyers go back to this data. And that's how it's official. This data is collected right after at night, right after the computer download everything. Then an automatic program check out to see if it's meaningful or it's from some parameters. And this is an automatic quality control. And when it's something wrong, they put a flag there. And in the morning, my colleague goes there and takes all these things and check them out to see why the flags are and are true or are not true. So that's manual computer-aided quality control. So we want to be sure that the data that's there it's a true accurate data. If it's not, then we put an estimated for a while from the surrounding stations. Or like you probably will see every winter, we don't record precipitation, the snow, we record only rain. So between November 1st and April 1st, we don't have precipitation recorded rain because it snows. And technology now is not accurate for snow measurements. We need to know to measure the water equivalent of the snow, not the inches of snow. So in order to transform that snow in water in a field, by the time you get water, it's evaporating already if it's 20 below. It doesn't have a chance to. Now, this is a cost that I started talking about at the beginning, and all these stations are connected by phone. So the big expense of it is a phone subscription, the phone line. Like everybody at home has a phone line, it's $32, $35 a month for the phone line. So that's what we pay for most of the phones. And some other people support their own phone there. So 35 times 12 is about $400, and then we call for troubleshooting and for other things. The phone, we talk to the county agents and other people to help us to see what's there. So we have long distance. We average it's about $75 a year. All these are a year, yearly. And then we drive state fleet truck, and the state, we rent it from the state, and we pay 40 to 50 cents. It's variable. This month we pay 44 cents. Probably later on, I don't know. We paid 48 cents at some time last year or so. And the average per year, per station is $225 that we have to pay to North Dakota DOT for this truck. And then all these sensors that you've seen on that previous image, all these sensors has to be repaired, calibrated, monitored. The ones that are broken are chewed, the birds sit on the tails of those things and so on. It's $150 a potentiometer there. And usually we have to send the sensor to manufacturer and receive it back in 5 weeks and pay $150 for the sensor plus labor, 200 and something. The thing is that we buy our own sensors and we place and calibrate in NDSU laboratory. So it's just the parts expense, which is there, is $300 per station. And that's only one example. And the rain gauge has to be calibrated, and the solar panel. 80% of the calibration and repair from this station is done in NDSU laboratory. And this is what the expenses are. Our salary is paid by NDSU, so it's not included there. So that's what means sponsor. If somebody sponsors a station, that means participate to these expenses that are very, very basic expenses. It's not money that we keep, it's not money that, it's money that we have to give to phone company, to DOT, and to buy parts. That's all. Now, we'll go to the website. This is the website address, and on ndsunodac.edu. So if you type that, you have it on your handout that Dwayne gave it to you. It's in several places written there. So if you type that, you'll have this screen. This is the home page. You have North Dakota with the station marked with a dot, name, and the numbers in black. Numbers and letters means where practically the station is located. For example, Mott, it's 1 mile north. That means that number. If you go to Bauman, it's 4 miles west of Bauman. That's where the station is. This is a climatological definition type of the stations. Now, below, if you click in one of those variables below, in that 3-column table, you get all North Dakota, what happened yesterday, what the wind was, what the rain was, what the max temperature, mean temperature in everywhere in North Dakota. And you can go a previous day or next day if you are in the middle of last week or something. And on the left side, that is very important. You have different other choices, like this is what I told you. And you have the name of the station. In a future version of this, you'll have, when you click on a station, you'll have the sponsor who gave us pays the phone, the money, whoever sponsored that will be there, will be latitude, longitude, and other pictures of it, and some other detailed information about the station. Now, these are the most important things there: weather data, monthly report, and application. These are the 3 main buttons. If you go above disclaimer and the overview and help, it'll telling you what sensors are, how they measure, what formula for diseases, everything in detail what we did to have this working the way it has. And then you have some links there. If we click on weather data, you get the table request form. This is how you get a table. You click on weather data and then you want a daily table. If you want a daily table, then you have to choose a time period. And you have this kind of drop-down menus, and daily or hourly or weekly, or that's a time period of choice, I called it. And you can go here, you see the hourly, you can get it 2 choices. You get from pull-down menu, or you will go farther and get the tables, hourly, daily, or maps. This where you can select all these things. It's very explanatory. You have to go through all. You have selected time period to last 7 days, last 14 days, last 30 days. So it's very easy to go for whatever you want. And the table included the name of the stations that you get in a previous. So practically 1, 2, 3, select station, select variable, and select time period. And the monthly report, you don't have to select time period because you select only the station. You see on the first column there, it's every station. Since the year is since we installed the station. Some of them are from 1990, 2001, bow belts, and so on. Variables that I explained you. Some of them calculated. You have dew point, wind chill, minimum wind chill, battery voltage in a second column, and then you either pre-selected time period, or you have a calendar, which is very, very easy to use. This calendar. It's the best calendar that exists on a web available. So you have to select the days for beginning date, and behind the yellow box there, it's the ending date. So you put your dates that you want the weather table to be from. And the weather table looks like this. This is a daily table, and all the variables, mean, max air temperature, average bare soil, average tube soil, and so on. And up there you have what station is, pardon, all the information here. If you click the green button there, you automatically go, and that column, you have a graph out of it, right? To see for the period you selected how the graphic works. And if you have 2 of them, for example, bare soil temperature and turf soil temperature, then you have 2 lines, different colors that goes and shows you how the temperature goes overnight, over day, in the morning or so, because it's different. The turf soil, it's temperature under some vegetation, grass, weeds, whatever. In case, like in a rainfall, I told you, in case we don't have values there, we have missing or estimated if it's a problem with a phone line. we cannot access the station, or the sensor is bad, or something happens, and we estimate that value. How do we get a map? The same thing. Choose a time period. These 3 clicks. And then you select the station variables that you need, period of time, this way. And you get a map. I'll show you the map later. Now if you click application, you have practically what it's interesting more for you. It's this application, table, and maps. Again, the same thing, applications, barley, degree days, growth stages. Or you can click applications there, and you have this table that comes and shows you all the crops that we have application on. In barley, we have degree dates and growth stages. Canola, we have degree dates, growth stages, sclerotinia risk. In corn, we have degree days, and I want to make a parenthesis here. Last year, I've been at the Corn Growers Association meeting, and I show this that the corn is least developed from this point of view, and they right away funded the 2-year research for NDSU. I don't know if you are familiar with Joel Ransom, and he is going to study this corn that you guys are growing it here. It's a shorter season, and has a different model of disease and development there. Potato, sugar beet, sunflower, wheat, small grains. So all of these are there. So everything is in blue. You can click on that, and you'll see further how you can put. You see planting date, number 2. You plug your own planting date for the station. You select the number 1. You plug planting date, and the end date is today date. If you want to follow your crop in a season in the same time, or if you want to go from last year, you can compare it with last year, see how it was last year, and so on. And then you submit, and this is for tables. And for the map, you do the same thing in the right side of the screen. And you have a table kind of like that. And every day, what's the max temperature, the wheat growing degree days, and so on. Estimating on stage, and you can graph it the same like that. You maybe know more. I'm not in agronomy, so I know these names because I work with them, but practically you have a better knowledge of what this disease means and how you handle that.
Yeah, I don't have any.
See, it's a sample of a graph.
Industry.
There are 2 stations, Cavalier and Oaks there, and that's a comparison. And this is a sample of a map of a growing degree days for wheat. So you know if it's coming. If you follow this every day or every other day or so, you see the rate is increasing or is decreasing. It depends what the weather is like. Insect degree days, it's similar, beginning date, ending date for the crop you want. Crop diseases, request form and results. You get the table, and the table looks like the one on the right side. Severity values, accumulated severity values. So you have a copy in that handout so you can look at potato blight, severity value map. See those people there, red spots. Some probably is combined with the soil, type of soil they have, and that the formula that this disease they have, it's an overview there, and what pattern and what formulas they use to come up with these maps and so on. These models are done by the people in plant pathology and plant science, which is the floor above us. And we have, when we work on this disease, we have meetings with them every week, and they come up with practically a formula, and then the computer IT guy is coming and transforms that formula in whatever needs to show these maps and tables. This is an application for crop water use. Again, tables and maps. Select the station, that's all. Select the crop. And in other things in information that you need in this order. 1, 2, 3, 4, 5. And of course time periods, and this is how the table with crop water use shows like that. And all these numbers, you see there, it's export. Oh, wait a second. It's you see up there, export CSV file. For who knows, you can click on there and you get this table and put it in spreadsheet. So you can print it and do with these numbers whatever you want to do. Crop water use, crop deficit, the same pattern. It's very easy to learn. This is how a crop water use map looks like. Crop water deficit. And we are working now on the next release of this website. We'll have departure from normal, departure from previous year, and departure from 5 years average. And this is a preview of what we do. We have this already on our experimental version of the website where we test something before releasing them. And this is a sneak preview there. Daily data table for, you can add columns. It's more improved and easier to use. So we are still working on this. This departure for full time. It's just a similar pattern that we, in sugar beet, this is sugar beet for the Red River Valley, the departure from normal. And this is for wheat, accumulated degree days. And I think that's all my slide presentations that I had to show how to navigate through the website. In regard to money, all this website was possible because 4 years ago we got a grant from National Weather Service to help us spread this information and dissipate whatever this weather station collect to tell you guys. And so we bought voice modems to all stations and put them. Now it's available. Every station has a voice modem. You can call it and get 10 minutes average of the whatever it's now, wind speed, wind direction, temperature, and all other things. And we hired 2 people to do this website the way it is now. So the money ended. One of them was let go, and the other one is supported now by another department and work on until 1st of July, when we hope we'll find more money for his salary to keep him ongoing. The only thing is that we have to pay the phone. NDSU pays right now 40 or around their phone bills out of 68. So the rest of them is National Guard pays one, some other Crystal Sugar pays, I don't know, 10 of them. And Potato Growers Association pays some of them. And then the county, each county, some of the towns up there in Ross, and so they pay, I don't know if Ross, but some other town, they, everybody in a town in a county pitch in $100 or so to pay for this phone and the truck, and that's how the station works. And there are many people who wants to. For example, we moved one from Walhalla because nobody there wanted to support it, so we kept it and tried to find some support for 2 years, and then somebody in Lisbon begged us to have one there. So we moved it from Walhalla to Lisbon. The same, we moved it from Northwood to Grafton, and so on. And we were to move Robinson, at the point to move Robinson this spring, and Jamestown, because we didn't find any support there, so we couldn't pay the phone bill and all that other expenses I showed you. And we got support from Bismarck now for these stations for 2 years. So that's what they can end on, kind of was. And in my appreciation, in my evaluation of it, I've been at different conferences and so. I think from this point of view, agricultural network, weather network for agriculture, we are one of the best in the United States. We receive phone calls from other states who want to be part of it. Minnesota, Montana wants to be part of it. And I think it's too far to spread, too much to spread us so far and so on. They ask us, how did you do the website? How did you do that? It's a wealth of information. South Dakota has 9 stations, and they are working to make 12 or 15 or something like that. Nebraska has about 50 something. Iowa has 7 or 8. So I think we are the best, and we are free of any cost except the one that I explained to you. So if you have some question, that's all what I have to say. I can answer any question if I know the answer.
Radu, maybe just a comment. I
Yes.
go on the website, the information is listed according to time, and the time is in Central Time.
Yeah, always.
We are at Mountain
Yeah, good. Always, we don't want to mess with these numbers, so all the stations, they have the central standard time, no daylight time, no mountain time, no nothing. All of them, even if it's in Mott or in Williston or Sydney, Montana, we are still central standard time to be a consistency all over, and this way we can compare one with another without being confused by the time range. So, yeah. And we don't change for daylight time and for, we just let go the way it is. So if you use these numbers, then you are down to the hours. We receive many inquiries from lawyers and so on that between this and this hours an accident on highway, and the guy claims that it was foggy outside, I couldn't see, and this and that. So the lawyer asked us weather and from that station, and hourly weather between 1 and 2 o'clock p.m. or 7 and 8 in the morning. The wind was 6 miles an hour, 7 miles an hour. So when it's 7 miles an hour, you don't have fog. So his claims that it's foggy and I didn't see didn't stand, because was driving with a combine or on the downtown and didn't type that that arm, didn't type it well or so, and hit a sign of a business or something, and said it was 25 miles an hour wind and took it up and so on. And they checked the hours, and there's no 25 miles an hour wind, it was barely 5 or something. So the reason it,
What height is your wind speed indicator?
all the stations are standard, exactly. If you don't know, all looks the same. Absolutely the same. Same program, same thing. Wind speed, I should have put it there, it's 10 feet. The National Weather is another thing. National Weather Service standard, when you hear on radio or on TV or so, the wind is so much. That's a 33 feet. It's 10 meters. That's the National Weather Standard. And the wind at 10 meters at 33 feet is much higher than a wind at 10 feet. So this information from our station will never match what you hear on TV, you know, the big wind blow 80 miles an hour. That's at 33 feet. In our station might be 55, 60, whatever the different direction and so on.
So is that what EPA wants us at? Is that where EPA is taking our wind
I don't know what the EPA wants. I don't know that. The temperature at 5 foot. All this information are in that overview for health. If you go there, you can find all this information there, but it's good to know that.
Is there a way to update it so that we can get real time from our offices at 7:30 in the morning without calling? But if we were to convert these to wireless internet, is that a capability of the system?
We are talking about these things, and we looked at the benefits and cost to see it costs a lot to go wireless instead of phone. It's true that the phone adds every month and every year to the cost, but in order to go wireless on internet, you have to have we can do radio from the station to somewhere within line of sight. Many of these stations are out of line of sight. And I know for these disease models and so, we didn't find any too much advantage to this to have it on, because you need, when you go to spray, you are in a tractor, you call the station and you know, or something. You are in a field and you call the station. Is that more than to go in an office? Well, I don't know. We don't have that support. We barely made this to be dependable and to spend this money to make this website. But it's a future project, we think of it. Because the technology goes so fast that already the computers that we have in every station, even those that we bought 2-3 years ago, they don't make them anymore. So we have 6-7 spares there just in case, and they are going to repair them for another 5 years or so if it's something wrong with them. But we have to think to change this system somehow in the future. But that requires 68 stations. If it's $1,000 outfit for wireless, then will be a lot of money. So we try to keep it for a while, as long as we can, until we are sure what we want to do, to see what technology is available and what the request is. You see, we have even hardship to find this phone money and truck money and repair money. So we don't dare thinking farther than that.
Is there any difference, do you think, at 3 feet compared to the 10 feet on the wind speed? Just back to this question with EPA, I'm just, who sprays at 10 feet?
I don't know what's the difference between, and anyway, it's not a formula that you can apply, and that's, it's very complicated because, for example, the wind direction, in the formula that the electrical impulse from that wind vane that goes like this is transformed in a 360 degrees and all that thing. It takes in consideration the wind speed also. It's a function of wind speed also, so it's very complicated to go from 30 feet, plus there are gusts, there are different, one of the things we wanted, when we installed the station, we didn't want to be any obstruction of around 1,000 feet around the station, not to disturb the wind that comes and so on. Now, depending where you measure at 33 feet and so many variables. I know it's possible the guys from national, when the Olympics were in Utah, they didn't have this kind of network, so many stations and so standard. So they took information from National Weather Service, from small private airports, the guys who from the ski area, from everywhere, from National Forest Service, and they took all kinds of information and they tried to make a kind of formula, way to bring them to the same base that can compare it. But it was very complicated. A lot of people work for that thing. So we are just 3 of us. You see in those papers, it's the new director that came now. It's a Professor John Enns, who probably heard of John Enns, retired in September. We hired somebody else, Dr. Adnan Akuz, and he has 115 students this semester. And he started job on Monday, and Wednesday he was teaching 115 students. So, and it's me and my colleague who does quality control every morning and so on. So it's just 3 of us, 2.5, that handle all these things. So I think it's very efficient and very,
Well,
we provide a lot for.
I think they're doing a heck of a job, and you got a heck of a resource there.
Thank you very much,
Let's
guys.
give John a hand. Got a little bit of a change. I don't know, sometimes communication breaks down, and it's been a good day for that, I guess. But we're going to adjust our schedule a little bit. We're going to have Eric on next, give us a quick update. I would like to say a few comments, carry on a little bit more what Purdue brought to us today. We've had our station here, we've had local sponsors, so we've had Mott Grain, MAGA Equity, Ag Alliance, Fitter, Sales, I believe the Commercial Bank, or Local Crop Improvement.
Chica, cel mai...
You have a wire stripper if you want to use that.
Okay.
But I got used to this, so for me it works better. So
For this video, we are adding a solar panel. So we add that in there.
we are in the solar panel, and it's already one here on a charge. You see here, charge. You can zoom if you see or whatever. You see this how it's connected?
Yeah.
Come here, right here. You see charge, and black and red. So you take the black out from here and take the red out because they're too short. So you have to enlarge them a little bit, and you put the red. You put the red here. Up, and you are not going to need the yellow one because the yellow one is the modem, and the yellow one you take it out. Okay, so you are going to put the other black here in the ground. I adjusted a little bit.
This is the one you took out. And now you're...
Yeah, it's too short now. I have to go kind of, I can force it the way it is, but it's not good to force anything. So I just cut a little bit more, like this, to have more wire, you know. I have here a better tool to do this. To cut this, you see. So now this allows me to have a little bit more. And the other red will be on the other charge here. You check them again, see if they're snug to tight, okay. And the ground you'll put together with the other ground. And in this way you have 20 watts on a panel. And you have a schematic, you have a page, color page in your reading binder, where it is telling that this wire will go red to separate and together on black.
Gotcha, makes sense.
And then you wrap them around nice here, and you put this back. Okay, now to finish that thing, let's go, because you film, let's go and tape it. So you tape it right away when it comes out from the dot logger. So it's this one. You see this one here? So I put here and I tape it. And it's already put in here, go like this. They tape it here again, all of them. Okay, and the rest of them are here like that.
Very nice.
And then if it's loose, so then it has to be too tight. This learn it. That's amazing how that goes. So now we take these 4 screws out. See? And you know how they go. You release them a little bit and you slide them out.
Yep.
And the only thing that I'll use out of this thing, modem, is this baby. This is a grounding that already exists, and I'm going to use this as a I'm going to use this as a jumping, and I'll do this to be nice.
That's a good idea.
Okay, so I already put from switch control, right? See how it is now? Switch control to C1, but in C1, like we looked, remember we looked on a wiring diagram?
Yeah.
The orange, this is orange, so this is HMP. This is, see, the diagram is wrong. It's HMP 35. For HMP 45, move C5. Let's see if C5 works. See, put this on C5. And put this to C1. Right, the jumper goes to C1 for cell phone.
Yes.
And move the HMP to different one. We'll see if it works. So let's slide this out and out, and take this out from here because I don't need it, and this, so I can put it here just to keep them together, you know, when I throw them in the back there. So this is to bring back. Now the phone, I don't want to cut it yet until I don't make this work. I'll see when I call the... So this is how it goes. Boom. This. Bam. Here. Emery Lagasse, and boom, salt. Boom.
Boom.
And you tight this here. Very important, this to be tight, you see?
Mm-hmm. Just like in the lab yesterday.
Yeah. Because in a winter you don't know if this react and dilate and shrink or whatever. And So we can, so the position now, I consider the position to be the best position to be this. I consider. You may consider differently later on, according to your own experience. And I try to put this somehow over like that. And leave this, to put the keyboard in it. So it's supposed to be handy, and hide this thing here, and then back of that. You see?
Perfect.
And this is the power, that's why I cut it short. And now I'm going to put this in.
Yeah, good thing you cut that short.
You see? This has to be up here somewhere. Don't have to interfere with my... So this is 12 volt here. Okay, and this is ground, right?
Mm-hmm.
Now this phone is ready to be connected.
Perfect.
It's ready to be, it's working now. You see the lights in? You see the lights?
Yeah, I see them.
You see?
And then you have to, yeah, the power and the...
Yeah, there are on 2 of them.
Mm-hmm.
Its activity, the network didn't blink yet. So, if this works, then I'll take this out completely. And I'll take it from here, I'll show you. By the time the lights go out of business, I'll show you here. You see, this phone thing has 2. This you need a special tool to open. This you can open it with everything. So I can open this. You have this, every person has at a house, on a house. So you can open. And here I have my cable. So I can take it out from here, or sometime it's in there. Anyway, you take it out. You see it's a hole here. You see you can take this and you push this through and put this back. Oops. So we can put this back here now. And close the thing. Okay, and now this and this. Garbage, garbage, garbage. So this is a phone cord that we have to take with us. Let's see what the lights are doing here. Yeah.
Isaac. Let me see if I can zoom in. Holy.
Can I have the can I have the can I have the AAA's?
They're on my desk.
Oh, I don't want to get up.
They're at the base of my monitor. The zoom on this is really smooth and really good. I like it. Has a night vision mode. Turn night vision plus. Interesting. Hello. I'm recording so I can attempt a playback. The playback did not work last time, so I'm trying to get it to work. End recording. The viewfinder also is not working as I think it should, or am I stupid? How does a viewfinder work? Whoa! Holy fuck!
Holy shit!
Oh. I'm recording my voice right now for no reason as I take a photo. Photo taken. It's a GIF.
I'm gonna fill all your ice trays.
Okay, how is super far zoomed in? How do I? This is so cool! Oh, has such a cool like coloration to it.
Can I see it?
Oh, it's like flip it around. It's like super high refresh rate. Feel that? Here, move it around.
60 FPS. It's interlaced. You're recording. Hey, stop that.
I am.
The things, this wouldn't fit to this pipe, so I put an extra. That's the reason for that. So you see now?
I see that.
Can't stop that from now on. Antenna and the wires and the second battery. You see, I put this thing here instead of in top. See, charging regulator and the battery next, and then it's enough.
Perfect.
But I cannot do this only in a small box. The new box is small and stuff. I don't need this. Always I use too much cable, so I don't need it.
Okay.
Xavier.
Yeah, give it to me to do that one. Come on. Don't frustrate yourself. Where is the... This thing, you see, it's important how you route this above the pipe and then inside. Stop a little bit, yeah, and use, you know, so somebody can come and buy seed hanging out or something. And right here, when the split is,
Oh, Radu. Didn't you want to put those in there or not?
no. Nah. You wanna put them in? from here.
It's only going to be a short distance. So.
Yeah, but this is few years, and then 3-4 years. What do I care after that? It's Michelle here. Huh?
Gosh.
What do you think, huh? Hey, tell the guys that only pound that how a foot or a foot and a half. You wanna get the level?
This way.
Calibrated in one
Okay.
1/100th of an inch per pip.
So it does this side and that gets filled and it tips and fills the other side and just goes back and forth.
And then drains out.
And then drains.
So,
Okay.
does this as calibrated if it's very horizontal or very vertical, whatever.
Okay.
So this has to be installed here to be perfectly horizontal.
Okay.
In every spring you receive a letter from Barb
Okay.
saying go and see if this is horizontal. So
Okay.
you put a
Oops.
put
Yeah.
a 8-inch
like, oh,
level
no.
like that on
On the
here,
top.
like this
See
and
this
like
level.
this.
Okay.
And if it's not, then you make it.
Okay.
So now I'm installing it and tell you how to make it.
Okay.
Horizontal.
All right.
Okay.
Oop. Oop. They're back in their spot.
The way
Did
this
you want
thing
it built up
stays
right?
there, it's with this.
Okay.
Okay. Okay, so this is too small. Yeah. And this has to be horizontal, and there are a lot of reasons not to be horizontal.
Okay.
One of them is this one.
Okay.
You know, you can put a pipe in the ground, but so I put this here. I can't untight it because so the way I horizontalize, you see, you put that thing here like that,
Oh, so I should
and then you twist this. You see this?
Oh, okay.
You see from here, you move this, and then goes where it's supposed to be.
Okay.
And if it's other way is not good, you put here a washer under.
Okay.
You know, to,
Yep. Move it back or take the washer
or
out.
here.
Yep.
Depend how it's supposed to be. So,
Right.
but on these two directions,
Uh-huh.
and then it's easy.
I'll need to get your email address. Okay. That's
So I
easy.
put you and Tom on as contacts for this station.
Newcomb?
Yeah.
Okay. Yeah.
That's it. I don't think I can do it more. So now it's level, right?
Okay.
Put this thing here. If say you look to see if
Okay.
it's clean.
Clean. Yep.
If not, you can take this thing out. You see, from here, this is springy steel stuff. If you take out, then you take that out, and then you.
And you can clean it out.
Yeah. So this is springy, just to keep. The wind blows this thing.
Sure.
And these are for birds, right?
Oh, okay.
Now, there were 3 of these. One of it fell. I don't know where is it. Can we find it? It's copper color. So you can measure through this, like this.
Yep, and if it's level,
Okay, and this way.
it's looking good.
So there we go.
Okay, that's easy.
And now we pipe this thing. Put a pipe on it and we'll bring it and connect it there. So.
You know, Barb, I may have to come and dust off if the trucks are here.
Oh, that thing.
Okay, where's that go?
This goes like that.
Unfortunately,
So
you might need a ladder.
see this?
Oh, I'll just get a feather duster thing, like for doing like a fan light or whatever.
Oh, it's where you put stuff on.
Yeah, you can. You see
Oh,
this?
I have to put some.
Especially when the birds
Here.
sit up there and poop on it.
Oh,
Maureen,
yuckers.
this stays here.
Yeah.
And the point is that white to be clean.
Okay.
The white dot here. And sometimes the birds go in the mud there after rain and then come and sit here.
They do.
On this. You see this stays here like that.
Okay, and what gets dirty then?
The white dot.
This
Yeah.
this white dot
Yeah.
This
Either poop on it or put the paws on it or whatever
to clean it off. Yep.
and leave dirt here.
Right.
If it's
And
not,
then it's not so sunny
Yeah.
for.
if it's
Right.
really, really badly not level, just let.
And it's
Those
a
guys
bubble
know.
here that and blue and red. You see blue and red. Blue and red. That is 7 and 8, 9 and 10. So these are staying here now.
Okay.
And I'm going to put a bag of desiccant, a bag of some desiccant, one here, one here, one here, just to absorb the moisture.
Sure. Okay.
Before I. So that's kind of what it is, you know.
Okay.
And now I have to put this wire in and this wire in and that wire in and all the wires have to come through here and connect it according to this.
To there.
And then it works.
Then it works, except for the signal.
We'll have to monkey with the antenna
Yeah.
because let's see. You see, it's no signal.
None at all.
Not at all.
It's been working on the website perfectly.
I got my cell phone and see what I got.
Oh, that's what I was gonna. Mine's in the truck. I can do the same thing.
Did you say we were meeting in the morning tomorrow, Radu?
The what?
When's our meeting? In the morning?
I have no idea.
Oh yes, you if you wanted to.
You.
Sure.
So that's how it works. We have a. Where is the tape?
I've got.
You mean the stuff in my pocket?
Call it filming me talk.
What?
How I'm looking for the tape.
I know.
You have
Well, I'm
to-
looking at that. That's a brown. Brown is always fair, right? Always.
Yeah, just.
This is my first week.
My signal on AT&T is.
Dying
Now we
and
can laugh at you instead of laugh at me.
you have to
do something.
you have to take the sideway. You see the
Uh-huh.
thing like that, and press on this, not too hard, not to the max. Press until you feel it, some resistance, and then turn it like that
To take off the end.
to
of
take
these.
off the end and cut it.
I've never seen one of these before.
You see, like that.
Hey, let me do that.
You see, put this in here.
I need to. Can I do that last one? Nope.
You get to do all
No,
the
you
other
do it from the beginning. This I put those. You just come and cut it. Put it. Put here. Put there.
ones. Everywhere there's black tape.
All right, sounds fun.
And yeah, and we need to put the rain gauge here. Oh. Well,
See, because you push it down.
you see what it does? It's tightening when you so you don't want it. You adjust the tightening as much as you want, and then you twist like this, It's written in a P2, so the P2 is here. What color is P2? Black. Black and P2.
Got my sunglasses on and I can't see colors.
Yeah. So black it's in a P2, and then white, of course, it's in a AG, which is ground. And we put that in the same ground because that's how it is. Okay. So this is connected now. You have something against Barb?
Do what now?
To be here, this solar panel? Do you have something against that?
Is it okay there?
Oh, I don't know.
Because she's telling the boss then that I did I don't know what. And
Somebody might, a bird might sit up there and it might poop on it. I don't know. Maybe we should put it on the other side of the road.
yeah, I took care of the light post.
Maybe we should put it.
So, Michelle, come on. Nikki.
You know her name is Nicole, right? We've run through all different names today.
You gotta get a name tag.
No, she can claim me as a harassment and bullying and stuff, you know?
Oh, I don't know. Well, she hasn't taken that test yet, so she
didn't?
Yeah.
So she doesn't
She's blissfully ignorant of that right now.
I can be in trouble, big one.
Of course, I am getting it all on tape.
Yeah, we have the evidence.
Yeah, now we're laughing, but who knows? I'm sorry. Okay. We have to put this here. Okay, and take this and start with your hand that is smaller than mine. And
Take these little guys again.
yeah, the same order. No, from the under. Under is better. Under, yeah. Oh, just your hand out.
See. There you go.
Okay, now go on the other side and I'll do that. I'll continue. See, I do this like this. I look from above and I do it from the bottom with.
Yeah.
And on this, okay.
So you do it like that.
Yeah, that's how you have to do it. Come on. There you go. Here, you see?
Okay. Yep.
Red signal, black volt excite, white signal reference is telling here too. So the red goes to power. Red is SC is 5. This doesn't have. Single-ended 5, right? Single-ended 5 is this one, you see? Or it's called 3H. Okay. What's the next? Orange. No, I'm sorry. Wind vane.
Black.
E2. So where is excitation 2? Here it's called VX2. So this is VX2. You can go on the other side and do it better, I think.
Okay.
Because you can see everything from there. So in the white it's AG and G. Okay. And this together. So we have to have wind now. But the wind we have to turn it around a little bit the north to get the calibration in it, right?
Right.
Okay, so the other, this is pyranometer. The pyranometer it's SE6. SE6, that's red wire. SE6 is the next one. RAG. Okay?
Yeah, I got, it was negative 81.
What is this?
Stop it.
Okay, let's go. See how come the door is open? Now come here. Right here at 45 degrees. And I put them in my... Okay, now go south. This is the south view. We're going to have the sun in. It's the
1 sec, it didn't go.
they make movies, they have a kind of harnesses that goes behind the shoulders and around the hip.
Have the